The representation of the value of a 16-bit unsigned integer x in hexadecimal number system is BCA9. The representation of the value of x in octal number system is, and we have been given 4 options. So in the question they have given us a number in hexadecimal and then we need to convert the number to octal. So converting from hexadecimal to octal would be easy if we convert it to binary first. So let us write down the number. Hexa is BCA9. We need to convert it to binary first. Now B will be in binary 1011, C is 1100, A is 1010, 9 is 1001. So this is the number in binary. So when we convert a number from binary to hexadecimal, we can do it directly by coupling the numbers of 4 bits together, each 4 bits together, and then converting it to that digit in hexa. Similarly, from binary to octal, when we are doing, how we do that is we couple 3 bits, each 3 bits together, and then we convert that to octal. Okay, so for converting this to octal, we will be coupling it in bits of 3. So the first 3 bits starting from the least significant bit is 001, now that is 1, 101, that is 5 in octal, 010 is 2 in octal, 110 is 6 in octal, 011 is 3 in octal. Now here there is only 1 bit, so we can assume 2 zeros to the left side, so that is 001, that is again 1 in octal, which means in octal the number is 136251. So option A is the right answer. Match the following. So this is a C programming question. Here they have given us 4 statements from C program and they have given us 4 meanings as well, and then we need to match the statements to its corresponding meaning. So we will go through these one by one. P, static car var. So let's read the right side. It's a sequence of memory locations to store address. That's not correct. A variable located in data section of memory. Now that is correct. Static car is a variable located in data section of memory. So we'll match P to 2. Q, m equals m alloc of 10, m equals null. So what has happened here? We have allocated 10 memory locations to pointer m and then we are making pointer to null, meaning that this location, memory location which we got allocated, now that is lost. There is no way to get the address of the locations back, right? So let's look at the options. Sequence of memory locations to store address. Now that is true, we get a sequence of memory locations, but let us look at other options as well. A request to allocate a CPU register to store data. No, that's not correct. For a lost memory which cannot be freed. Now that is true. So this is a lost memory. We can match it to this as well, but then this is a better option and there is another one which will match to this. We'll see that now. So Q is 4. R, car star pointer of 10. So that is what we can match it to sequence 1. It is a sequence of memory locations to store address. To store address part is true because it's a pointer. So it's an array of pointers. So R will match to 1. S, register int var. Now that matches to this, a request to allocate a CPU register to store data. That is register int. We are saying that var should be stored in a register. Again, it's a request to the compiler. The request may be satisfied or may not be satisfied. So S is 3. So the answer is P is 2, Q is 4, R is 1, S is 3. That is option. Match the algorithms with their time complexities. So we have been given 4 algorithms here and 4 time complexities are also given here, and we need to match each of these to the one on the right side. So let's look at these one by one. Tower of Hanoi with n disks. Now Tower of Hanoi is an exponential algorithm. So that is 2 power n. If you don't know Tower of Hanoi, please refer to the video lectures from algorithm sections and you can learn it. So that takes exponential time. That is theta 2 power n. Binary search given n sorted numbers. Binary search is only takes log n complexities on sorted numbers. So Q is 4, theta log n. Now R, heap sort given n numbers at the worst case. In the best case or worst case, heap sort will give you theta n log n time complexity. So heap sort will match to this n log n. Now S, addition of 2 n by n matrices. In an n by n matrices there will be n square elements. So adding 2 matrices like that, we need to do n square addition. So the complexity is theta of n square. Now we look at the options. P is 3, Q is 4, R is 2, S is 1. P is 3, Q is 4, R is 2, S is 1. Option C is the right answer. Let L1, L2 be any two context-free languages and R be a regular language. Then which of the following is or are correct? 1. L1 union L2 is context-free. 2. L1 complement is context-free. 3. L1 minus R is context-free. And 4. L1 intersection L2 is context-free. So this is a question from theory of computation regarding closure properties of regular and context-free languages. So here I have given a table for closure properties of regular and context-free languages. So in order to learn the closure properties of all the languages and various other properties as well, and also the proofs to all of these, please refer to the video lectures from theory of computation section. You will get a bigger table there and the proofs also for all of this you can learn. It is better to learn that because in GATE there are many questions of this type regarding various languages asked. So please learn that. Now we'll come to the question. L1 union L2 is context-free. So if you look union for context-free languages, it's given that union of two context-free languages is closed. That means if you're taking union operation of L1 and L2 and the new language, that will also be context-free. So context-free languages are closed under union. This is true. L1 complement is context-free. So if you look at the table for intersection, I have given a cross here, meaning that context-free languages are not closed under intersection. So this is false. Now L1 minus R is context-free. R is a regular language. Okay, so L1 minus R, we can rewrite it as L1 intersection R complement. Now R is a regular language. R complement will also be a regular language because regular languages are closed under complementation. So L1 intersection R is nothing but intersection with a regular language. Now these context-free languages are closed under intersection with regular languages. So this will always be a context-free language. For L1 intersection L2 is context-free. Context-free languages are not closed under intersection as I have given here. So this is false. So you can see that only 1 and 3 is correct here. So the right answer is option B, 1 and 3 only. Match the following according to input from the left column to the compiler phase in the right column that processes it. We have been given various representations of inputs, and in the right side we have been given 4 compiler phases, and they are asking us to match from left column to the right column depending on what is the input to this compiler phase. So this is a question from compiler design. I will show you the stages in a compiler. So the first stage in a compiler is lexical analysis. Lexical analysis will output a stream of tokens. After lexical analysis we do syntax analysis. Now syntax analysis will output as the syntax tree there. After that we do semantic analysis. Semantic analysis will be, the output would be a semantically verified syntax tree. After that there the stage is intermediate code generator. Now the intermediate code generator will take this semantically verified syntax tree and then will output some intermediate representation of the code. One example is 3-address code. Now the final stage is the machine code generator that will take the 3-address code and then output the final target code or the machine code, whatever is required. So based on this info we'll look at the options. So P is syntax tree. Now we'll take the right side first. Take lexical analyzer. What is the input to the lexical analyzer? If you look at the stages, lexical analysis that stage will take whatever is the program that as input. Now a program is nothing but a stream of characters. So to this phase the input would be a character stream. From character stream that would be the input to lexical analyzer. Then let's look at syntax analysis. Syntax analyzer. Now the input to that would be whatever is output of lexical analysis, that is a stream of tokens, right? So a stream of tokens will be matching to syntax analyzer. Then the next stage is semantic analysis. Semantic analyzer. The input to that is whatever is output of syntax analysis, that is syntax tree. So semantic analyzer will be taking syntax tree. And then the final is code generator, that is machine code generator. The input to that is whatever is the intermediate representation, that would be the input. So that is given here. 1. So if you look here, the options are for P it is 3, Q it is 4, R is 1, S is 2. Option C is the right answer. Which of the following statements about parsers is or are correct? 1. Canonical LR is more powerful than SLR. 2. SLR is more powerful than LALR. 3. SLR is more powerful than canonical LR. And we have been given 4 options. So this is a question from compiler design regarding the expressive powers of the parsers given here. So please refer to the video lectures to learn about these parsers and also their expressive powers. So the powers of these I have given here. LR0, these are all LR parsers, okay. In LR parsers, LR0 is the least powerful. After that comes LR1 or SLR. After that it comes LALR, and the most powerful one is CLR. CLR is canonical LR. Now based on this information, let us look at the options. Look at the statements. 1. Canonical LR is more powerful than SLR. This is more powerful than SLR. Yes, that is correct. 2. SLR is more powerful than LALR. No, SLR is less powerful than LALR. LALR is a more powerful one. So this is false. 3. SLR is more powerful than canonical LR. No, that's also false. SLR is less powerful than canonical LR. So option 3 is also wrong. Statement 3 is also wrong. So from the options, one only is correct. So that is option A. Which of the following is or are shared by all the threads in a process? Program counter, stack, address space, registers, and we have been given 4 options. So this is a recurring kind of question. Even in 2017 set 1 also a similar question was there. Which of the following were shared by a thread? So I have given an elaborate diagram here of whatever is shared and whatever is unique for each threads. So this is a program and these are 3 threads here. So if you look here, each thread, whatever local data it needs, that won't be shared. So for a thread execution, it needs stack, it needs its own program counter, and it will need its own registers, etc. So these won't be shared. But the rest of the data associated with the program, the code, will be same for all threads. Data, heap section, files. So the entire address space, all of these will be shared by threads. So if you look here, program counter is, the question was which of the following are shared. Program counter is not shared, address stack is not shared, registers are not shared, only address space here is shared. So the answer is option B, 3 only. In a file allocation scheme, which of the following allocation schemes can be used if no external fragmentation is allowed? 1. Contiguous, 2. Linked, 3. In-text. So this is a question regarding file allocation schemes coming from operating systems, and they are asking which of the schemes we can use if no external fragmentation is allowed. So I will give you an overview of external fragmentation and internal fragmentation here. Suppose this is the file system, and this is one file allocated here, another file allocated here, and another file allocated here, and these are free spaces. Imagine, suppose we have another file which will need as much space as the total of these 3 free spaces. Imagine, but if we are using a contiguous allocation scheme, which means that we can allocate the file only in contiguous locations. So let us say this space is 3, this space is 2, this space size is 1, and we have a file of size 6. So we can allocate that file only in either this or this or this if it is contiguous. So we can't use up any of these if the file size is 6. But if all of these were combined together, we could have allocated the file. Meaning we have space for the file, but since we are using contiguous allocation scheme, we can't allocate the file. So this is what is called external fragmentation. Now this exists only in contiguous allocation schemes. Now coming to internal fragmentation. In internal fragmentation, that exists only in fixed partitioning schemes. Suppose these partitions here in the file are fixed. Imagine, so a file or a block of file will have to either use up none of a partition or entirely that partition. Suppose this is one file here, it is using up space up to here, but then this entire partition is allocated to that file. So this space, this part, that is wasted. Similarly, if you look at this one, a file is taking up to here, but this space is wasted. This we can't allocate to anyone else since it is a fixed partition scheme. Either this entirely or one partition entirely can only be allocated to a file. So this is internal fragmentation. Internal fragmentation exists only in fixed partitioning schemes. So based on this information, we can look at the question. They have asked only about external fragmentation here. Now one is contiguous allocation scheme. Clearly, as I have explained, in contiguous allocation scheme there will be external fragmentation, which I showed you just a while back. So this we can't use. They are asking no external fragmentation is allowed. Now linked allocation. Linked allocation means one block we will assign to some free space and then we will give a pointer to the next block, and then from there we will give a pointer to the next block in the file. So using linked allocation for our file of size 6, we can put one block here and then give a pointer to this block. We will put a block of size 2 here, then give a pointer to this block. We will put a block of size 3 here. So a file like this can be easily fit into this part. So there is no external fragmentation for linked allocation. So this is fine. Now indexed allocation. Indexed allocation means we will be dividing the file into blocks and then we will be putting those in free spaces, and then whichever blocks we are using, we will have another index block that will be storing the address of all the blocks that we are using. Meaning we will be having files in some random blocks like this. We will have another index block that will have a pointer or the address of whichever blocks we are using, so that we can find out the file is using which of these blocks. This also won't be having any external fragmentation. Using such a scheme also we can fit a file into this without any memory wastage. So this also won't be having external fragmentation. So the answer here is 2 and 3. That is option D. Consider the following statements about the routing protocols: routing information protocol and open shortest path first in an IPv4 network. 1. RIP uses distance vector routing. 2. RIP packets are sent using UDP. 3. OSPF packets are sent using TCP. And 4. OSPF operation is based on link state routing. Which of the following statements are correct? And they have given 4 statements. So this is a question coming from computer networks regarding routing protocols. So in GATE computer network syllabus, we have 2 main routing protocols given. That is, one is distance vector routing and the second one is link state routing. So please refer to the video lectures to learn how distance vector routing and link state routing works. So distance vector routing and link state working are the algorithms, and the protocol which implements them is RIP for distance vector routing and OSPF for link state routing. And in RIP, each packets are forwarded as using UDP. UDP packets are sent to different networks in RIP. Whereas in OSPF uses neither TCP nor UDP. Instead, it encapsulates its data directly into IP packets. So based on this information, we look at the options. Option 1, RIP uses distance vector routing. That's correct. RIP packets are sent using UDP. That's also correct. OSPF packets are sent using TCP. Now that is not correct. 4, OSPF operation is based on link state routing. That's also true. So the options are 1, 2 and 3. That is option C. If f of x equals r sin pi x by 2 plus s, f dash of 1 by 2 equals root 2, and integral 0 to 1 f of x dx equal to 2r by pi, then the constants r and s are respectively, and we have been given 4 options. This is a question from engineering mathematics regarding integration. This is a very simple question. We need to just take derivative and integration of the given function f of x and then equate it to the constants r and s. We'll see how to do it. First we will take the derivative of it. F dash x equals r sin pi x by 2's derivative is cos pi x by 2 into pi by 2, which means we have in the question we have been given f dash of 1 by 2. So f dash of 1 by 2 equals, we'll substitute 1 by 2 instead of x, r cos pi by 2 into x is 1 by 2, so it becomes pi by 4 into pi by 2. Now we know that is root 2 given in the question. We'll equate it to root 2, which means that r equals to root 2 into 2 by pi into 1 by cos pi by 4. Cos pi by 4 is 1 by root 2. So we can rewrite it as 2 root 2 by pi into 1 by root 2, that is root 2. Now this is 4 by pi. So r is 4 by pi. Now we'll see how to solve for s. For s, we have been given that integration 0 to 1 f of x dx is 2r by pi. So we'll see what this is. Integral 0 to 1 f of x dx equals integral 0 to 1 r sin pi x by 2 plus s. Now if you take derivative of cos pi by 2x, we will get minus sin pi by 2x into pi by 2. So integral of sin pi x by 2 is cos pi by 2x into 2 by pi. So we'll substitute that here. Now integral 0 to 1, this part is, we'll take the integral of constant. Integral of constant will be Sx. Now r sin pi by 2x integral will be r into sin's integral is, as we solved here, minus cos pi by 2x into pi by 2. So this becomes Sx minus r cos pi by 2x into 2 by pi. Now that we need to do definite integral from 0 to 1, right? So for this we need to substitute x value to 1 and then subtract it to whatever we get when we substitute x equal to 0. So on substituting x equal to 1, we get s minus r into cos of, when x is 1 it becomes cos pi by 2, that is cos 90, that is 0, minus r into 0. Now minus substituting x equal to 0, s into 0 is 0, plus minus of minus is plus, plus r into cos pi by 2 into x is 0, that is cos 0. Cos 0 is 1. So r into 2 by pi. So we get that equal to s plus 2r by pi. In the question it was given that integral was 2r by pi. So we can equate it to 2r by pi. From there we get s equal to 0. So r is 4 by pi and s is 0. C is the answer. Let P, Q, R denote the statements it is raining, it is cold and it is pleasant respectively. Then the statement it is not raining and it is pleasant and it is not pleasant only if it is raining and it is cold is represented by, and they have given us these 4 statements here. Now this is a question from propositional logic. We need to find out which among these is equivalent to the sentence given in English here. So there might be some confusion regarding how we should read it. One way to read it is not raining, it is pleasant and it is not pleasant only if it is raining and it is cold. So we can couple it is not raining, it is pleasant and it is not pleasant only if it is raining and it is cold. Or another way of reading it is not raining and it is pleasant, those two together. After that, and it is not pleasant only if it is raining and it is cold. So the first way of reading it is wrong. If you look at the option, you can see that always the first part, it is not raining, R is it is pleasant, only these two are coupled together and the rest comes later. So for reading it, we will put brackets here, it is not raining and it is pleasant. After that, and it is not pleasant only if it is raining and it is cold. So I can end the bracket here. So this we can read, it is not pleasant only if, we'll start a bracket here, it is raining and it is cold. So this is how we should read the statement. Now one more thing, what to do when a statement is given as A only if B. Now if the statement is A only if B, if you look at the statement we can say that if A is true then B is definitely true. A only if B. So if A is true, B is definitely true. This again I can rewrite it as A implies B. So A only if B is A implies B. Now we will look at how to assign the variables here. It is not raining, that is negation of P. It is pleasant is R, and it is not pleasant only if it is raining and it is cold. So that is A implies B. It is not pleasant only if it is raining is P, and it is cold is Q. So the statement is negation of P and R, and negation of P implies P and Q. So if you look at the option, that is option A, negation of P and R, and negation of, sorry, this was not P, this was R, pleasant was R. So, and negation of R implies P and Q. So option A is the correct answer. Consider the following binary number in 32-bit single precision IEEE 754 format. The decimal value closest to this floating point number is, and we have been given 4 options. So this is a question from digital logic design from number systems. They are asking us about IEEE single precision format. So IEEE single precision format and double precision format are there in GATE syllabus and you need to study both. So IEEE single precision format I have given here. In IEEE single precision format, that is used to donate decimal numbers in real. So in IEEE single precision we have a 32-bit binary number. The first bit will be assigned for the sign bit, and the next 8 bits will be assigned for the exponent part, and the next 23 bit will be assigned for the mantissa part. So whenever the sign, exponent and mantissa part are these, the value of the number is given here. Now sign bit can be 0 or 1 always. 0 means positive number, 1 means negative number. So the exponent and mantissa part, if exponent is 0 and mantissa is 0, the number is 0. If exponent is 255 and mantissa is 0, the number is infinity, plus or minus infinity. If the exponent is 0 and mantissa is not 0, then that is a number expressed in fractional form. Then the number is given as -1 raised to s, that is sign bit, into 0 point mantissa part into 2 raised to -126. If the number is 255, exponent is 255 and mantissa is not 0, then that is an invalid number. It shows not a number. And if exponent is between 1 and 254 and mantissa is any value, then that value of the number is in implied normal form, that is -1 raised to s as a sign bit into 1 point mantissa part into 2 raised to e minus 127. So you can refer to the video lectures regarding IEEE single precision or double precision in digital logic section to gain more understanding about this. So the given number I've rewritten here. The first bit is 0, so it is a positive number. The next 8 bits are 0, 1, 1, 1, 1, 1, 0, 0. This is 124. Now exponent is 124. It belongs to this part, 1 less than or equal to exponent less than or equal to 254. So this number can be written as -1 raised to s into 1 point mantissa part into 2 raised to e minus 127. So I have written that here, -1 raised to 0, mantissa part is this, 110, 1101, rest all 0. So the number would be 1.1101101 into 2 raised to e minus 127. E is 124. So 124 minus 127. Now that number is 1.1101101 into 2 raised to -3, that is 0.0011101101. This is in binary. Now we need to convert it to decimal. So when we are converting a binary to decimal, this is the dot part. So after this the weight of this bit is 2 power minus 1, the weight of this bit is 2 power minus 2, this is 2 power minus 3, etc. So this part, when we convert it to decimal, it would be 2 power minus 3, that's for this one, plus 2 power minus 4, plus 2 power minus 5, then we see 0, plus 2 power minus 7, plus 2 power minus 8, plus 2 power minus 10. So this will be 0.231445531. So roughly we can write it as 2.3 into 10 raised to minus 1. Now this option is not given. The closest one is option C, 2.27 into 10 raised to minus 1. C is the answer. A circular queue has been implemented using a singly linked list where each node consists of a value and a single pointer pointing to the next node. We maintain exactly 2 external pointers, front and rear, pointing to the front node and the rear node of the queue. Which of the following statements is or are correct for such a circular queue so that insertion and deletion operations can be performed in O1 time? 1. Next pointer of the front node points to the rear node. 2. Next point of the rear node points to the front node. So in this question, this is a question from data structures regarding circular queues. In the question, they have given us 2 implementation of a circular queue, and then we need to find out in which of the implementation insertion and deletion both can happen in O1 time. So let's look at the first one. Here, next pointer of the front node points to the rear node. So this is the circular queue which I have implemented here. Let us say there are 4 nodes in the queue. This is the front node, and the next pointer of the front node points to the rear node. This is the rear node. Okay. So next pointer of this one points to the rear node, that is node 4, meaning next pointer of the rear node will point to this one. Next pointer of this one will point to this. Next pointer of this one will point to 1. Actually, I put the arrow wrong here. So this is how the queue would look. Now let us try inserting or deleting. In a circular queue, insertions will happen at the rear node and deletions will happen from the front node. Okay. So for insertion, we will need to create a new node. Now we already know the rear node's address. So for this node, the next pointer, I can put it straight to this node. And then the front node, I need to point to the rear node, right? So this will become the new rear. And from the front node, I know the address of the node which I created just now. So this arrow, I will just put it here. Okay, so this is how insertions happen. Clearly, I did that in O1 time. So this is insertions. Now let us try deleting from here. Now deletions should happen from the front node. So what I should do is I should delete this node, make this one as the front node, and then this should point to the rear node. Now after deleting, for making this as a front node, I need to know the address of this one. But in the current front node, only the next address of rear is stored. In rear, the next address of this is stored. So in order to reach the address of this one, node 2, from front I need to go to rear, and I need to traverse like this, and I should reach the second node. There is no way to directly get the address of this node. Meaning for deletion, I can't do it in O1 time. It will take ON time for deletion. If I delete this one to get the address of the next one, which should be the front node, I need to start from rear and reach here. So this can't do deletions in O1 time. In the question they're asking, insertion and deletion operations can be performed in O1 time. So this we can't do that. Now we'll look at statement 2. Next pointer of the rear node points to the front node. So this is that implementation. Again, we have 4 nodes here. This is the rear node, this is the front node. Next pointer of the rear node points to the front node, meaning next pointer of the front node will point to node 2, this will point to node 3, this will point to node 4, etc. Now let us try inserting an element here. Insertion should happen at the rear node. So I will create a new node. I know the rear node. From here, this pointer I will make it to this one, and this I will make the rear node, new rear node. And from this node, I need to point to the front node. Front node's address also I know, so I can directly put an arrow here. So this is how we can do insertions. Clearly insertions can happen in O1 time. Now let us try deletion. Deletion should happen at the front of the queue. So this node I have to delete. After deleting this node, I need to make this node as the front node, and from the rear node I need to point to the second node. Okay. So clearly in the front node I have stored the address of the second node using this pointer. So this one's address I have directly from the front node. So this I will just directly make as front. Now this one's address I know. Rear I will point it directly to this node, and then after that I can delete this node. So clearly in this one deletion also can happen in O1 time. So in implementation 2, insertion and deletion both happens in O1 time. So this one satisfies the criteria of the question. Now there were 4 options given, 1 only, 2 only, both 1 and 2, neither 1 nor 2. So 2 only is the correct answer. B is the right answer. This is a question from C programming. Here they have given this following function in C, and they are asking us what would be the output of invoking print xy of 1 1, and 4 options are given here. So let's take a look at print xy. Let us say it is being invoked with 1 1. So x is 1, y is 1. Okay. So we are declaring an integer pointer named ptr here, and we are assigning x equal to 0. So let us say this is the variable x. Okay, the value inside x is 0, and let us say the address of x is 100. Okay, now here pointer equal to ampersand x, meaning the address of x is stored into that integer pointer. So suppose this is ptr assigned. Let us say the address of ptr is 200, and the value of ptr would be the address of x here. The address of x is 100. So ptr will have value 100 inside it, and then we are making y equal to star of ptr. So when we do star of ptr on a pointer, what it would do is it would go to the address where address contained inside the pointer, and then it will take the value inside that address. So the address inside this pointer is 100, and the value inside 100 is 0. So star of ptr will return 0. So y will be 0 now. Let us say this is y, the value inside y is 0, and let us say the address of y is 300. Okay, and here we are making star of ptr equal to 1. So ptr is 100, value inside ptr is 100. Now this is the address of x, right? So when we are doing value of star of ptr equal to 1, what we are doing is we will go to 100, and then the value inside 100 we will make it as 1. So this becomes 1. So what has happened here is that x has become 1 now. After that we are printing printf %d x comma y. So x has value 1, y has value 0. So the output would be 1 comma 0, that is option C. The breadth first search algorithm has been implemented using Q data structure. Which one of the following is a possible order of visiting the nodes in the graph below? So this is a question from data structures regarding breadth first search or BFS, and we have given 4 options. We need to eliminate 3 options and find the one option which is the correct order or a possible order of visiting the nodes. So let us look at A. A starts from M. So if you are starting from M, this will be the first node. After that it will visit nodes which are at distance 1 from M. So that will be N and R. After that it will visit nodes which are at distance 2 from M, which would be O and Q. After that it will need to visit P. Now if you look at the option A, it is given M, then N and then O, which is not correct. Before O we need R here, so A is wrong. Now we will look at option B. It starts with N. So if we start with N, N is at distance 0 from N, so that will be the first one. After that M, Q and O, these 3 should be coming. These 3 can come in any order, but these 3 should be the next 3 nodes. So if you look here, it says N, then Q, that is fine, M, that is fine, but then after that it is saying P. P is at distance 2, but there is already one more node O which is at distance 1 from N. So O needs to come before P, so this is wrong. If you look at C, it says it starts with Q, M, that is fine, N is fine, R is at distance 2 from Q, but there is another node O which is at distance 1 from Q, which needs to come before R. So this is also wrong. Now if you look at D, it starts from P, that's fine. After that it is O and Q. O and Q is at distance 1, that is fine. Then N and then after that N. N is at distance 2 from P. After that M. M is at distance 3. Then R. R is at distance 4 from here. So D is fine. D is the correct answer. Identify the language generated by the following grammar where S is the start variable. S gives xy, x gives ax or a, y gives ayb. And 4 options have been given. From the option we need to identify the language which is represented by the same as here. So this is a question from theory of computation and regular grammars. So let us look at what the grammar gives us. S gives x and y, okay. And if you look at x, x gives ax or a. So the smallest string generated by x would be a, and after that it can generate ax and x can give a, or ax, x again gives ax and x gives a. So similarly, so this will be a, etc. So that is what x would be generating. Now that we can write as a plus. Now if you look at y, y can start with epsilon, or then it can go to ayb and then y gives epsilon, that would be ab, or it can generate ayb and y again generates ayb and then y goes to epsilon, so that be aa, be, bb, etc. So if you look, y will generate strings of the format a raised to n, b raised to n. That's what I have given here. Y gives a raised to n, b raised to n. Now n can be greater or equal to 0 here because epsilon is also allowed there. So what S gives would be this and this combined together. That is, we have n a's here, n b's here, and before n a's there will be one or more a's also. So we can write it as a raised to m, b raised to n. Now n would be greater or equal to 0. M will be greater than n because this part there will be at least one n, meaning combining this with a's here, the number of a's will be greater than the number of b's here. So this is the final language, and if you look at the options, that is option C. An ER model of a database consists of entity types A and B. These are connected by a relationship R which does not have its own attribute. Under which one of the following conditions can the table for R be merged with that of A? And we have been given 4 options regarding the relationship between A and B. So this is a question from DBMS section regarding ER models. Here they are saying that A is related to B through this relationship R, and under which of these conditions can the table for R be merged with that of A? So the answer to that is that when the relationship is many to one from A to B, then the table for R can be merged that with A. A many to one relationship is given like this: A, R, B, and M is on A side and 1 is on B side. It's a many to one relationship. Under this condition, we can merge the table R with that of A. How we can do that, I will show you here. So consider this table A, that is student. Now it has two attributes. One is name and one is ID. Let the students be A, B, C, D and ID be 1, 2, 3, 4. And consider the table B as department. It also has name and ID. Now there are three departments, physics, chemistry and biology. ID is 1, 2 and 3. Now let the relationship be that a student is in a particular department. That we can give as this relationship student ID, department ID. Let us say student 1 is in department 1, student 2 is in department 2, student 3 is in department 1, student 4 is in department 2. So if you take a look at the relationship here, it is clearly a many to one relationship. For each department here, there can be multiple students. Department 1 has students 1 and 3, department 2 has students 2 and 4. Also, for each student here, there is only one department. Student 1 has 1, student 2 has department 2, student 3 has department 1, student 4 has department 2. In this case, this is the table for R. But we can easily merge it with that of the student table. If you see, for each student, there is only one department. So we can just give that department ID here. We'll have one more table, one more column in this table called department ID, and then we can just write the department ID here like 1, 2, 1, 2. So this is how I have merged R with that of A. Now we could do this because A was a many to one relationship, and also students' participation was total in R. Every student had one department ID. If the participation was not total, let us say there was another student named 5 which did not have any department, then we would have had to write something like null here. So since the participation was total and it was many to one, we could have easily merged R with that of A. So that is given in option C. Consider a socket API on a Linux machine that supports connected UDP sockets. A connected UDP socket is a UDP socket on which connect function has already been called. Which of the following statements is or are correct? We have been given two statements here and they are asking which of these are correct. So this is a question from computer networks regarding UDP. So let's look at the statements one by one. 1. A UDP socket can be used to communicate with multiple peers simultaneously. Now this statement is false. Even the UDP is connectionless. In a Linux machine, the UDP socket will have a specified IP number and a port. One IP number and a port will uniquely identify one peer only. So using one socket, after calling connect on it, we can only use it to communicate with one peer only. We can't use it to communicate with multiple peers. So this statement is false. Second, a process can successfully call connect function again for an already connected UDP socket. This statement is correct. We can call connect function again on a connected UDP socket to change the peer and use it to connect to a new peer. So this statement is correct. So the right answer is 2 only. Option B. Consider the following tables T1 and T2. In table T1, P is the primary key and Q is the foreign key referencing R in table T2 with on delete cascade and on update cascade. In table T2, R is the primary key and S is the foreign key referencing P in table 1 with on delete set null and on update cascade. In order to delete the record 38 from table T1, the number of additional records that need to be deleted from table T1 is dash. So this is a question from DBMS topic regarding referential integrity. So let us look at the constraints. Q is the foreign key referencing R in table T2. So Q is a foreign key that is referencing R in T2 and it is saying on delete cascade, on update cascade. Meaning if something in T2 is deleted from here, we need to cascade the deletes. So let us say if we are deleting row 3, 2 from table T2, then we will need to delete whoever is referencing 3. So for example, 7, 3 is referencing 3 here. So 7, 3 will have to be deleted in such a case. That is called on delete cascade. On update cascade means whenever something is updated here, that update also has to be cascaded here. Now the other constraint is R is the primary key and S is the foreign key referencing P in table T1. So this is also a foreign key that is referencing P in table T1 and it says on delete set null and on update cascade, which means that whenever something in T1 is deleted, whoever is referencing that P value in table T2, that also should be deleted. So meaning, so that should be set null, I'm sorry, on delete set null. Okay, so if I am deleting 2, 2, let us say, so whoever is referencing 2 here, see S is referencing P column here, so whoever is referencing 2 here, now that is this row only, 2, 2 is referencing 2 here, that row S value should be set null, that is called on delete set null. So with this information, let us look at the question. In order to delete record 38 from the table, the number of additional records that need to be deleted from the table T1 is. So we are deleting this column 38. So if you look at this here, this column is referencing 3. 3 is coming from P here, and the constraint is on delete set null, meaning this 3 we need to set as null now, and that's it. Nothing more is deleted. Nothing more is getting deleted from this table. If you look at this row, R value is 8 and there are more rows referencing 8, but here we are not deleting this. We are only setting this value as null. So there are no more deletes required from this table. If it was on delete cascade, then we would have had to delete this row. In that case, 8 would be gone and whoever is referencing 8 would also have to be deleted, but it was on delete set null. So we'll just set it as null, and that is all the operations required. So the answer is 0. The maximum number of IPv4 router addresses that can be listed in the record route option field of an IPv4 header is dash. So this is a question coming from computer networks. They are asking us about record route option in IP. So in IP there are various options available. One of those is record route. So what record route does is that it records the IP addresses of the routers in the path from source to destination inside IP datagram headers option field. So when we are sending an IP datagram from source to destination, if the record route option is turned on, then on each hop, that is on each network, on each router, whatever is IP address of the router, that will be saved in the record route field in IP options. So when it reaches the destination can look at the IP datagram and see the path which was taken by the IP datagram from source to destination. Now the option field of IP datagram is 40 bytes. Now, and the size of one IP address is 32 bits, that is 4 bytes. So it may seem that we can store a maximum of 40 by 4, that is 10 IP addresses here. But in the option field out of 40 byte, some space we need in order to specify what the type of option is. So record route is not the only option, there are other options as well. So you need to specify that, and also to specify the length of the options field. So options field is maximum 40 byte. It can be any length less than 40 also. To specify that length, etc., we need to reserve some space out of this 40 bytes. And in the remaining space out of the 40, we can save up to 9 IP addresses. You can refer to the video lectures to see how record route works and other IP options, etc. So for this question, the answer is 9. Consider the set X equals A, B, C, D, E under the partial ordering R equals AA, AB, AC, AD, AE, BB, BC, BE, CC, CE, DD, DE and EE. The Hussey diagram of the partial order XR is shown below. The minimum number of ordered pairs that need to be added to R to make XR a lattice is. So this is a question from set theory and algebra regarding partial orders and lattice. So in order to answer this question, you need to understand what a partial order is, what a lattice is, and how to get Hussey diagrams out of a partial order given. Now this is the partial order that they have given here, and this is the same information conveyed in the form of a Hussey diagram, and they are asking how many ordered pair we should be adding in order to make it a lattice. So a partial order is said to be a lattice if it has greatest lower bound and least upper bound existing for any pair of elements chosen from it. So in a partial order, for every pair of elements that we choose, if there is a greatest lower bound and least upper bound existing for every pair chosen like that, then that is called a lattice. Now greatest lower bound and least upper bound. So what is least upper bound? For any A, B belonging to A out of any partial ordering given, C is the least upper bound if A is related to C and B is related to C, and for any D such that A is related to D and B is related to D, C must be related to D. If this condition is true, it is called a least upper bound, and greatest lower bound is for any a comma b belong to set A. C is the greatest lower bound if C is related to A and C is related to B in that partial order, and for any D such that D is related to A and D is related to B, D must be related to C. If that is true, then C is called the greatest lower bound of A and B. So if you don't understand these concepts, please learn least upper bound, greatest upper bound, lattice, etc., partial order, etc. before coming to this question. So once you understand this, we can come to solving this. So if you look at the Hussey diagram here, every pair of element has a least upper bound and greatest upper bound, greatest lower bound. Why that is so? If you take A and B, the greatest lower bound is A only here, and the least upper bound will be B here. If you take A and C, A is related to C, as you can see in this, and also there is a path from A to C in the Hussey diagram. That means that A is related to C. Since A is related to C, C will be the least upper bound for A and C, and also A will be the greatest lower bound for A and C. Similarly, for A and E, the greatest lower bound would be A and the least upper bound would be E. Similarly, whatever pair of numbers you choose out of this Hussey diagram, it will have a greatest lower bound and least upper bound. So the number of pairs that we need to add to this Hussey diagram is 0. Let P equals 1, 1, minus 1, 2, minus 3, 4, 3, minus 2, 3, and Q equals minus 1, minus 2, minus 1, 6, 12, 6, 5, 10, 5 be two matrices. The rank of P plus Q is dash. Now we'll find the rank of this matrix. This is a question from linear algebra, rank of matrices. So first we'll do P plus Q. P plus Q is 0, minus 1, minus 2, 8, 9, 10, 8, 8, 8. Now we will do elementary transformation in this matrix, and then we'll find out if some rows we can convert to 0. So if I do row 2 equals row 2 plus row 1, that is this I am adding this and this. Now this will become 8, 9 minus 1 is 8, 10 minus 2 is 8. The rest of the rows are same. Now we can see that row 2 and row 3 have become equal. Now I can do row 3 equals row 3 minus row 2. Now row 3 will become 0 now. After that I can do row 2 equals row 2 plus 8 R1. Now when I do 8 R1, 8 plus 0 into 8 is 8 only. 8 minus 8 into 1 is 0. 8 plus minus 2 into 8 is minus 8, and these are 0. Now I will do row 2 becomes row 2 by 8, row 1 becomes row 1 by minus 1, and I will swap row 1 and row 2. Now when I do row 2 by 8, this will be 1, 0, minus 1, and this when I divide with minus 1, it will become 0, 1 and 2, and when I swap it, this is the final matrices 1, 0, minus 1, 0, 1, 2, 0, 0, 0. Now this is in reduced row echelon form. To understand what reduced row echelon form is, you can refer to the video lectures for linear algebra, rank of matrix, and understand that. So basically reduced row echelon form means any row having more zeros before the first non-zero element should appear below any row having more zeros before the first non-zero. So this has 0 zeros before the first non-zero one, and this has 1 0 before the first non-zero element, and this has all zeros, so that will be the last row. And also in this row, this is 1, and in this entire column this is the only non-zero one. Here also in this column this is the only non-zero one. So anyway, this has become 0, so this won't be considered in rank, and these two vectors are linearly independent, so there will be two linearly independent vectors in this matrix. So the rank of this one is, we can write 2. In reduced row echelon form, after removing all the rows which became 0, whatever is remaining, that is the rank. So this is 2. G is an undirected graph with n vertices and 25 edges, such that each vertex of G has degree at least 3. The maximum possible value of n is, so this is a question from graph theory in engineering mathematics. They have given us that G is a graph having 25 edges and that each vertex has a degree of at least 3. Then what is the maximum possible value of the number of vertices in this graph? So If you know the relation between vertices and sum of degree of vertices and edges is that sum of the degree of all the vertices will be equal to 2 times number of edges. The reason for this is that if you consider an edge like this edge will add degree of 1 to this vertex and also degree 1 to this vertex. So each edge will add a value of 2 to the sum of degree of vertices. So sum of degree of vertices equals 2 into number of edges, which means average degree of vertices will be the sum of degree divided by the number of vertices, right? So that will be 2 into number of edges. This is the sum of the degree of all the vertices divided by number of vertices. This will be the average degree of each vertex in a graph. Now minimum degree of a vertex would be less than or equal to this average degree, and maximum degree of a vertex will be greater than or equal to the average degree. So we can write it like this: minimum degree of a vertex less than or equal to 2 into number of edges divided by number of vertices less than or equal to maximum degree of a vertex. Now in the question they have given that minimum degree is 3. Degree of every vertex is at least 3. And that the number of edges is 25 and vertices is n. So we can put these values into this equation. Minimum degree, that is 3, less than or equal to 2 into number of edges, that is 25, divided by n is the number of vertices. So this will give us that n is less than or equal to 50 by 3, i.e. n is less than or equal to 16.666. Now n is the number of vertices, it should be an integer, that is less than or equal to 16.66. So the answer is 16. Consider a quadratic equation x square minus 13x plus 36 equals 0 with coefficients in a base b. The solutions of this equation in the same base b are x equals 5 and x equals 6, then b equal to dash. So this is a question from number systems. They have given us this quadratic equation and then they are given us that the solution is x equal to 5 and x equal to 6. But these numbers 5, 6, 13 and 36, these are not in base 10, these are in some base b which we don't know, and the question is what the base b is. So let's look at the digits here which we have, that is 6, 5, 13 and 36. If you look at the numbers, the largest digit is 6. So if 6 is a valid digit in this base b number system, then the base should be greater or equal to 7. If the base was 6, then we could only use digits from 0 to 5, 0, 1, 2, 3, 4, 5 for base 6 number system. If base is 7, then we can use digits from 0 to 6. So since 6 is used here, we can say that base is greater or equal to 7. We will come back to this at the end. Okay. Now suppose we have a quadratic equation ax square plus bx plus c. In the case if we have two solutions also given, then sum of the solutions would be equal to minus b by a and the product of the solutions will be c by a. So here we have been given the solutions are 5 and 6. In that case 5 plus 6 will be equal to minus b by a, that is minus of minus 13 by 1, that is 13, and the product 5 into 6 will be c by a, that is 36. Now these numbers are not in base 10, these are in base b. Okay, so in base b 5 plus 6 in base b will be equal to 13 in base b. Now 13 in base b we can rewrite as 10 plus 3. Now 10 is not 10 here, 10 is 10 in base 10. In base b 10 will be b. So we can rewrite it again as b plus 3. Now if I write it in base 10, I can write that 5 plus 6 will be equal to 11. 5 plus 6 is 11 in base 10. That is equal to b in base 10 plus 3 in base 10, which means that b will be 8 in base 10. So now we got that base b will be equal to 8. Now we can verify this. We have also been given 5 into 6 equal to 36. So 5 in base 10 into 6 in base 10 will be 30. Now 30 will be 3 into 8 raised to 1 plus 6 into 8 raised to 0. Now this in base 8 we will write as 3, I take from here, and 6 I take from here, 36 in base 8. Now this was correct, the 36 was the number we got. So the base is 8 and the initial condition was that base should be greater or equal to 7. That's also true. So 8 is the answer to this question. The minimum possible number of states of a deterministic finite automaton that accept the regular language given as W1, A, W2. W1, W2 belongs to A, B star. Length of W1 equals to 2, length of W2 greater than or equal to C is dash. So this is a question from theory of computation regarding finite automata. We have been given this regular language and we need to construct the DFA, the minimal DFA accepting this language, and then we need to find out the number of states in that minimal DFA. So we will try to do that. So if you look at this language, W1 is A comma B star, it can be anything from A or B. W2 is also A comma B star, same. W1 has a length equal to 2, W2 has a length greater than or equal to 3, and there should be an A in middle. So this is nothing but A or B 2 times and then 1A, and then A or B at least 3 times. So this is the set of all strength of length greater than or equal to 6, such that the third one will be A. The third alphabet in the string should be A. So let's try to construct this DFA here. So this is the starting state. On seeing A or B, I'll go to the next state. On seeing A or B, I'll go to the next state. This is to count the length. So here the length is 0, here the length is 1, here the length is 2. Now we have successfully got the string W1 here. Now after that I have to see an A. If I see a B, then this string won't belong in the language. So on seeing an A, I will go to the next state, length 3. On seeing a B, I will go to some rejecting state, and here whether I see further A or B's, that will still remain the rejecting state. So on seeing an A, I will go to this state. After that I need to see W2, that is 3 or more times A or B. So on seeing A or B, once again I'll go here, now the length is 4, A or B once again, I'll go here, now the length is 5, A or B once again, here now the length is 6, and this will be an accepting state. Now W2's length has become 3 here, as you can see, and it can be greater or equal to C. So on further A or B's we see it will keep on remaining in this state only. So this is the minimal DFA that accepts this language, and this has 1, 2, 3, 4, 5, 6, 7, 8 states. So 8 is the answer to this question. P and Q are considering to apply for a job. The probability that P applies for the job is 1 by 4. The probability that P applies for the job given that Q applies for the job is 1 by 2. And the probability that Q applies for the job given that P applies for the job is 1 by 3. Then the probability that P does not apply for the job given that Q doesn't apply for the job is, we have been given 4 options. So this is a question from probability theory. So if you are drawing the Venn diagram for this, then this question becomes easier. So let us say this is the Venn diagram, and this circle represents the probability that P applies for the job, and this circle represents the probability that Q applies for the job. Now these areas I will denote as A, B, C and D. So B means P applies for the job and Q applies for the job, and D means neither P applies for the job or Q applies for the job. Now the total area of this Venn diagram would be 1, that is the total probability, meaning A plus B plus C plus D will be 1. Now with this knowledge, let us try to answer the question. Now if you look at the question, it's given that the probability that P applies for the job is 1 by 4. So this circle represents P applies for the job, and the value of that will be 1 by 4, meaning A plus B will be equal to 1 by 4 here. Now the second condition is that the probability that P applies for the job given that Q applies for the job is 1 by 2. So this is the circle that says that Q applies for the job, and this part represents P applies for the job and Q applies for the job. So P applies for the job given that Q applies for the job is P and Q applies for the job, that is B, divided by the total of Q applies for the job, that is B plus C. So this part B divided by this whole part B plus C gives the probability that P applies for the job given that Q applies for the job. Now that is in the question given as 1 by 2. So B by B plus C equals 1 by 2. From this we can deduce that B equal to C. This I will write as 2. Now the third condition is that Q applies for the job, probability that Q applies for the job given that P applies for the job is 1 by 3. So this circle represents P applies for the job, and this part divided by this part gives the probability that Q applies for the job given that P applies for the job, just like we did here. So the probability would be B divided by the total of this, that is A plus B, that is given as 1 by 3 in the question. So B by A plus B equals 1 by 3. From this we can deduce that A equals 2 times B. So we will rewrite the conditions again. One is A plus B is 1 by 4, and from 3 we got a equal to 2b. So here we can rewrite it as 2b plus b is 1 by 4. On solving that, we will get b equals 1 by 12. Now a is 2b, so a is 2 times of this, that is 2 by 12. And in condition 2, we had got that b equal to c. So c will be 1 by 2, that we got from 2. Now d will be 1 minus a plus b plus c. I told earlier that a plus b plus c plus d was the total probability, that is 1. So d is 1 minus a plus b plus c. That is 1 minus 2 by 12 plus 1 by 12 plus 1 by 12. That's equal to 1 minus 4 by 12. That is 8 by 12. Now we can try to answer the question. The probability that P does not apply for the job given that Q does not apply for the job is what? So this circle shows Q applies for the job. So whatever is outside, that is this part, including this part, gives that Q doesn't apply for the job. So the part that Q does not apply for the job is D plus A. Okay. This gives Q doesn't apply for the job. And they are asking the probability that P also does not apply for the job given that Q doesn't apply for the job. So P also doesn't apply for the job, that is this part, in the part that Q doesn't apply for the job. So there is only this part D, that is P doesn't apply for the job and Q doesn't apply for the job, that is D. So the probability that P does not apply for the job given that Q does not apply for the job, we can write as D divided by D plus A. That's equal to 8 by 12 divided by 8 by 12 plus 2 by 12, that is 4 by 5. Now that is option A. If w, x, y and z are Boolean variables, then which of the following is incorrect? And we have been given these 4 options. So among these, on the left side is given an expression and to the right side it's given a minimized expression they have given us. So in these we need to find out which one is incorrect. That's what is asked in the question. So we'll go through these statements one by one. A is wx plus w into x plus y plus x into x plus y. That's the LHS part. So we'll try to minimize this. We can take x into this. So that will become w into x plus y plus x into x plus x into y. I am expanding that here. So if you look here, x and x plus x, it's adding here, that will be x only. So that will be w into x plus y plus xx becomes x plus xy. That is wx plus wy, I am expanding this, plus x plus xy. Now if you see, we have x plus xy here, that we can rewrite as x into 1 plus y. Now that will become wx plus wy plus x into 1 plus y. Now x into 1 plus y will become x only, 1 plus something is 1 only. So this part will be x, that I can write here, plus wx plus wy. Now if you see here, x I can take common, that we can rewrite as x into 1 plus w plus wy. Again this will become 1 plus w, so that minimized form will be x plus wy, which is given in RHS here. So statement 1 is correct. Now let's look at B. W x complement into y plus z complement the whole complement plus w complement x. Now ABC the whole complement is a complement plus b complement plus c complement. Now that I will rewrite here, w complement plus x plus y plus z the whole complement and plus w complement x. Now again a plus b the whole complement is a complement into b complement, that I can write here, w complement plus x plus y complement into z plus w complement y. So if you see here, here there is w complement and here there is w complement into x, that I can rewrite as w complement into 1 plus x. Now that 1 plus x will be 1 only, so this part I will rewrite as w complement plus x plus y complement z. That is given in RHS. So B is also correct. We look at statement D here. So D is w plus y into wxy plus wyz, that I can expand and write w into this plus y into this and y into this. That will be wwxy plus wwyz plus wxyy plus wyyz. Now w and w into w will be w only. Same here, same happens here, y into y is y. Same happens here also. So that I can rewrite as wxy plus wyz plus wxy plus wyz. So if you see here, wxy is coming twice, wyz is coming twice, so we only need to write it once. That is wxy plus wyz. That's the same thing given in RHS here. So D is also correct. Now look at C. Wx complement into y plus xz complement plus w complement x complement into y. This I will expand and write it here, wx complement into y plus wx complement into x into z complement plus w complement x complement into y. Now if you see here in the same product, x and x complement is appearing and x into x complement will be 0 always. So this will become 0. So the rest is wx complement y plus w complement x complement into y. That y, this I will expand and write wx complement into y plus w complement x complement y. Y is appearing twice here. I can reduce that, wx complement y plus w complement x complement into y. Taking y outside, we will get y into wx complement plus w complement x complement. From here I can take x complement also outside, then it will give y x complement into w plus w complement. W plus w complement will be 1 always. So the final answer is x complement y. But in the option if you see, they are given xy complement, which is not correct. So C is the right answer here. They are asking for which of these was incorrect. Given f of w x y z equal to sigma m of 0, 1, 2, 3, 7, 8, 10 plus sigma d of 5, 6, 11, 15, where d represents the don't care condition in Carnot maps. Which of the following is a minimum product sum form of f of w x y z? And we have been given 4 options. So this is a question from digital logic design on the topic minimization using k-maps. So if you don't know how to minimize a function given in this form using k-maps to find out the minimum sum of product or form, please refer to the video lectures for k-maps and learn the procedure first. So in the question I will show you how to do it for this question. So here it's given that m is the condition for sigma. Okay, it is 0, 1, 2, 3, 7, 8, 10. So it means that in the k-map 0, 1, 2, 3, 7, 8, 10 should be 1 and d is the don't care condition. So 5, 6, 11 and 15 will be don't care. So that I will mark as x in the k-map, 5, 6, 11 and 15. Now here they are asking us product of some forms. So and in the min term these are 0, 1, 2, 3, 7, 8 and 10. So 0, 1, 2, 3, 7, 8 and 10 should be marked as 1 and the rest after the 1 times and x times the rest will be zeros as marked here. So the 1 time I have not written here because for finding out product of sum we don't need to use ones, only zeros and x terms we need. So these are the 0 terms and these are the x terms. Now we need to find out prime implicants from this k-map such that we can minimize this. So if you see there is 0, 0 here, so we can couple these two zeros together. But when you look at the top there is a 0 here and there is a don't care term here. So if I put this x as 0, that means I will be able to take a prime implicant of size 4 like this, which is bigger than the initial one which I was trying to take. So this I cannot further expand to the right side. I can't do this part also, here it is non-zero. So this I can't further expand. So this is one group. Now if you look there is a 0, 0 here, so I can take these two together. But then if you look to the bottom of this there is 2 x's here. So if I take these 4 together I will get a bigger prime implicant. And I can't expand it further as here it is 1, here it is 1, to the right side also these 2 is 1. So this is only 2 prime implicants possible. This I can mark as 1. So I just need to take these 2. Now we will find out the expression corresponding to these. So if you look at this block, w changes from 0 to 1, so we won't be taking w. X changes from 1 to 1, so we can take x. Now since it is POS form, for 1 we need to take the complement of this, that is x complement, plus y changes from 0 to 1 here, so we won't take y. Z changes from 0 to 0, so z is 0, meaning that we will take z also, so that is x complement plus z into, for this block w changes from 1 to 1, so we will take w complement as written here, and y changes from 0 to 1, z is constant 0, z is constant 1 to 1, so we will take z complement also. So this is the expression for these two blocks. So the final is x complement plus z into w complement plus z complement. Now if you look at the options, that is option A. In a two-level cache system, the access times of L1 and L2 caches are 1 and 8 clock cycles respectively. The miss penalty from L2 cache to main memory is 18 clock cycles. The miss rate of L1 cache is twice that of L2. The average memory access time of this cache system is 2 cycles. the misrates of L1 and L2 are respectively, and we have been given 4 options here. So this is a question from computer organization regarding caches. Here we have been given an L1 L2 cache system, which means that initially there will be an L1 cache. If that's not there in L1, we'll look in L2 cache, and if it's not there in L2 also, then we'll look in the main memory. And they have given that the access time of L1 cache is 1 clock cycle, and the access time of L2 cache is 8 clock cycles, and if it's not there in L2 cache, for going to main memory it will take 18 clock cycles. The average memory access is given as 2 clock cycles, and what they have given us is that the misrate of L1 cache is twice as that of misrate of L2 cache. So let's try to solve this question. Suppose misrate of L2 cache equals to m, then misrate of L1 cache will be 2 times of m, that will be 2m. Now we have been given average memory access time in this question. So the formula for average memory access time will be L1 cache's hit rate into access time for L1 cache access time, plus L1 cache misrate into again L1's access time we need to add, plus L1's penalty time. So if it's there in L1 cache, we will be adding L1's hit rate into L1's access time to the average memory access time. If it is not there, we will be adding L1's misrate into, again we need to access the cache once, L1 access time plus L1 penalty time. Now what is L1's penalty time, we will see here. So here you can see L1's access time into L1 hit rate, L1 access time into L1's misrate, we are adding it here. So this we can take together. So we can rewrite it as L1's access time into L1's hit rate plus L1's misrate, that will be 1 only. So this we can rewrite as L1 plus L1 misrate into this part we already took here when we combined this, plus L1 misrate into L1's penalty time. Now what is L1's penalty time? L1's penalty time means it's not there in L1 and now we are looking in L2. Now what will be the time? The time would be just like we wrote here, L2's hit rate into L2's access time plus L2's misrate into L2's access time plus penalty time. Now this is the penalty time for going to memory. Now this part we can rewrite as L2 just like we did here plus L2's misrate into penalty time. Now L2's misrate is m, we wrote here, and L1's misrate will be 2m. So this equation we can write as L1 plus 2m into L2's access time plus m into penalty time. Now L1 access time was 1 clock cycle plus 2m into L2 access time was 8 clock cycle plus m into penalty time was 18 clock cycle. This data we got from the question. So this we can rewrite as 1 plus 16m plus 36m square. So this is the average memory access time, and in the question it's given that it is 2 cycles. So this we will equate it to 2. Now we got a quadratic equation, we just need to solve it to find m. So this equation I have rewritten here as 36m square plus 16m minus 1 equals to 0. Now to solve a quadratic equation, m will be minus 16 plus or minus, we don't need to take minus because m has to be positive for us. So it will be minus 16 plus root of b square, that is 16 square, minus 4ac, that is minus 4 into 36 into minus 1, that will be plus 4 into 36. So that will be minus 16 plus this will evaluate to 400, minus 16 plus root of 400 by 72. Root of 400 is 20. So 20 minus 16 is 4. This is 4 by 72, that is 0.056. So m is 0.056, meaning 2m is 0.111. 2m was the misrate of L1 cache and m was the misrate of L2 cache. So option A is the right answer. Consider the recurrence relation T of n equals 2 into T of root n plus 1, n is greater than 2, or it is 2 if 0 less than n less than or equal to 2. Then T of n in terms of theta notation is, we have been given 4 options here. So this is a question on solving recurrence relations. We have been given this particular recurrence relation and then we need to solve it and find the time complexity of T of n from these 4 options. So one way of solving recurrence relation is using Master's theorem. So what Master's theorem states that if we have a recurrence relation of this form, T of n equals a into T of n by b plus f of n, where a is greater than or equal to 1 and b is greater than 1. If we have a recurrence relation of this form, then we can obtain 3 cases out of this. Case 1, if f of n equals theta n power c, where c is less than log a to the base b, then T of n equals theta of n raised to log a to the base b. Case 2 is if f of n equals theta n power c, where c equal to log a to the base b, then T of n will be equal to theta of n power log a to the base b into log n. And case 3 is if f of n equals theta n power c, where c greater than log a to the base b, then T of n will be equal to theta f of n. So this is what Master's theorem states. If you didn't know Master's theorem, I would recommend please learn it from the video lectures or some standard textbooks. Don't rely on what I have written here to learn the entire thing. There are some cases such that in which it doesn't belong to any of these cases, etc. So please learn Master's theorem from standard textbook or the video lectures. So based on this, let us try to solve this question. In this question, the reconciliation they have given is T of n equals 2 into T of root n plus 1. Now this is not in a form where we can apply Master's theorem directly. For Master's theorem we need T of n equals to a into T of n by b plus f of n form. But here it is 2 into T of n raised to 1 by 2, that is root n. So we can't apply Master's theorem directly here. So we need to convert it to some other form so that we can apply Master's theorem to that. So let us try putting n equals to 2 power m. When n equals 2 power m, we can rewrite it as T of 2 power m equals to 2 into T of 2 power n by 2 plus 1. Now let us suppose T of 2 power m equal to S of m. If T of 2 power m equals S of m, then T of 2 raised to m by 2 will be equal to S of m by 2. T of 2 power m was S of m, then T of 2 power m by 2 will be S of m by 2. Okay. Now let's rewrite it again. T of 2 power m will be S of m, that's equal to 2 into T of 2 raised to m by 2 will become S of m by 2 plus 1. Now this is of the form a into T of n by b format, where a equal to 2, b equal to 2 and f of n is 1. So we can directly apply Master's theorem here. Now f of n equals to 1, which has a complexity of theta n power 0. Now c is 0 here in this format, and c is less than log a to the base b. 0 is less than log of 2 to the base 2. Log 2 to the base 2 is 1. 0 is less than 1. So it satisfies the conditions for case 1. So we can apply Master's theorem case 1 here. We can write S of m equal to theta of n raised to log a to the base b. So S of m will be theta of m raised to log 2 to the base 2. This is 1. That is theta of m. So S of m is theta of m, meaning T of 2 power m will be having theta m. So what will be the complexity of T of m? For converting 2 power m to m, we need to take log to the base 2. So T of m will have a complexity of theta log to the base 2 of m. So that's how we will solve for T of m. And from the options, that is option B, theta of log n. For any discrete random variable x with probability mass function p of x equal to j equals p of j greater than or equal to 0, comma j belongs to 0 to n, and sigma j equals 0 to n, p of j equals to 1. Define the polynomial function gx of z equal to sigma j equal to 0 to n, p of j into z raised to j. For a certain discrete random variable y, there exists a scalar beta belong to 0, 1 such that gy of z equals 1 minus beta plus beta z the whole power n. The expectation of y is, we have been given 4 options. So this is a question from probability distributions. This was a very tough question which appeared this year. This is tough because of 2 reasons. One is even understanding the question, it will take us some time to read and understand the question fully. And the second part is, even if we understand the question, in order to solve it also, we will need to know all the basics of probability distribution. Like we need to have a good grasp on probability distributions, expectation, etc. in order to answer this question. So I will explain the question first of all. So here the question is about what the expectation of y is. We need to find the expectation of y. So suppose for any random variable x, the expectation of x will be equal to sum of all the values of x into probability of x having that value. If x has values 1, 2, 3, etc., and then it has associated probabilities for getting that value, then the expectation of the random variable x would be the sum of all the values of x into the probability of getting that value. So in the question initially they have given us a random variable x. Now it's given that P of x equal to j equals P of j. So what it means that for the random variable x, for x having a particular value j, the probability is P of j. Meaning for x to be equal to j, the probability is P of j, and probability of j is greater than or equal to 0. Probabilities of everything should be greater than or equal to 0. And j belongs to 0 up to n. J can have values ranging from 0, 1, etc. up to n. And also it said that P sigma j equal to 0 to n, P of j equal to 1. Now this is the condition for this becoming a probability distribution. If x can have values from 0, 1, 2, etc. up to n, and with the probability, the sum of the probability of x getting value 0, 1, 2, etc. up to n, if the sum of all those probabilities is 1, then we can model it as a probability distribution. So this is just the condition for it to become a probability distribution. Now what is expectation of x here? Expectation of x is for every value of x, that value into the probability of getting that value. So that is nothing but sigma j equals 0 to n. The value of x is j into probability of getting the value j is P of j. Now if you see, this is sigma j equals 0 to n, j into P of j. Now when j equal to 0, this becomes 0 into P of j. This is not x, this is multiplication symbol, okay. So when j is 0, it will become 0 into P of j, so that will become 0 only. So we can eliminate that from this sigma part. So we can rewrite it as sigma j equal to 1 to n, j into P of j. So this is expectation of x. Now on top of x, they have given us a polynomial function gx of z that is equal to j equal to 0 to n P of j into z raised to j. So for our random variable x, they have given one additional polynomial function gx of z that will be equal to sigma j equal to 0 to n P of j into z raised to j. So what this polynomial function gives, we don't know, but they have given us this data. Now what we want is to find out expectation of y, right? So before finding out the expectation of y, let's try to find out what the expectation of x would be in terms of this particular polynomial function, because for y the only data we have is the same polynomial function for the random variable y, that is 1 minus beta plus beta z, this function and this function. So this is a function for x, this is a function for y. We don't know what this function gives. So but our aim is to find out expectation of y. So let's try to find out the expectation of x in terms of this polynomial function. So expectation of x, we found out it will be sigma j equal to 1 to n, j into P of j. So can we get this one from this one? This is sigma j equal to 0 of n, P of j into z raised to j. Now P of j is there here and here, so we already got P of j. Now to get expectation from here, somehow we need one j term. We need j into P of j for it to become expectation. But here we have z raised to j. So what's the way of getting this j outside and putting here? So if you look at this, if we take the derivative of z here, derivative of z would be j into z raised to j minus 1. If we take derivative of z, we can take this j outside and keep it into this expression. So let's try that out. Let's try taking g dash of x of z. Okay, g of x of z, the derivative of that we are taking with respect to z. So this is a function in z. Okay, so derivative of this will be sigma j equal to 0 to n, P of j is a constant, and z raised to j's derivative would be j into z raised to j minus 1. So g dash of z would be sigma j equal to 0 to n, P of j into z raised to j minus 1. Now again look at this, we need to somehow make this equal to this. Okay, so we got j term here, that's there, P of j is also there, and then there says z term here. Somehow we need to eliminate this. So the term is z raised to j minus 1. If we put z equal to 1, it will become 1 raised to j minus 1. Okay, that way we can eliminate the z term. So this I have rewritten again here, sigma j equals 0 to P of j into z raised to j minus 1. When j is 0, this entire term will be 0, so we can eliminate that. So that means we can rewrite it as sigma j equal to 1 to n, P of j into z raised to j minus 1. So same thing, I have just removed the j equal to 0 part. Now just like I said previously, we will assign z equal to 1. That will be g dash x of 1, sigma j equal to 1 to n, P of j into 1 raised to anything will be 1 only. So if you look at this, this and this is exactly the same. So g dash 1, g dash x of 1 will be sigma j equal to 1 to n p of j into j. So right now what I did is I have changed this function, I have modified this function some way that it becomes expectation of x. Now what I did here is I just took the derivative of this with respect to z and I made z equal to 1. So now we know what the significance of this polynomial function is. The polynomial function will give the expected value, expectation of the random variable when we take the derivative of this and assign z equal to 1. So that's how I got the expectation of x here, right? So now we understand what the polynomial function does. G dash x of 1 gives the expectation of x. Now it's the same polynomial function given for y, so meaning g dash y of 1 will give the expectation of y. So this is the important point which we need to arrive at in this question. Now once we got this, we can try to find out the expectation of y as well. So for y, the g polynomial function is given as this. So now we'll take the derivative of that. So derivative of 1 minus beta plus beta z raised to n will be n into beta into 1 minus beta plus beta z. How I got beta out is that 1 minus beta is a constant term, z is there only for this term, so I can take this beta out when I take the derivative of this. So g dash y of z will be n beta into 1 minus beta plus beta z all raised to n minus 1. Now for getting expectation, we not only need to get the derivative, but we also need to assign z equal to 1. So when I assign z equal to 1, g dash y of 1 will be n beta into 1 minus beta plus beta into 1, that is beta only raised to n minus 1. So this term is 1 minus beta plus beta the whole raised to n minus 1. So that becomes 1 only. This entire term will be 1 minus beta plus beta, this 2 will be crossed out. This will be 1 raised to n minus 1, that is 1 only. So this will become n beta. As I have written here, g dash y of 1 gives expectation of y. That's what we have calculated here. G dash y of 1 is n beta, which means the expectation of y is n beta. Now we look at the options. In options, B is the only right answer. Consider the following expression grammar G. E gives E minus T or T. T gives T plus F or F. F gives parenthesis E parenthesis or ID. Which of the following grammar is not left recursive but is equivalent to G? So this is a question from compiler design topic regarding left recursion in grammars. So what does left recursion means? If you look at this first production, E gives E minus T. So if you see, E gives E itself again. Now this E can again give E only, like this. E gives E. Now this E can again give E. So this can keep on going on like this. This is called left recursion. Now the problem with left recursion is, if there is left recursion in a grammar, then we can't use any top-down parsers to parse that grammar. To understand about left recursion and also why it won't work for top-down parsers, you can refer to the video lectures and gain more insight. So in the question, they have given this particular grammar and they are trying to eliminate left recursion in this grammar, and they are asking which of the following options is the correct grammar which is equivalent to this, which also does not have left recursion. So if you refer to the video lectures, you can see a procedure there for eliminating left recursion in grammars, but I won't be trying to eliminate left recursion in this grammar and obtain the final grammar, because already we have the option. So we just need to eliminate the grammars which is not equivalent to this or which has left recursion, and we can eliminate the option and find out the right answer. So I'll be using that approach for this question instead of directly trying to eliminate left recursion here. So to understand how to eliminate left recursion, for that procedure, as I said, please refer to the video lectures. So let's take a deeper look into this grammar. So what does E generate? E gives E minus T. Now E again can give E minus T, and this E, let us say I am resolving it to T. So if you look at this expression, what I have got is T minus T minus T. So in this part, T minus T minus T becomes T minus T. This is the bracket where we should apply. After that, this minus T happens. So we can say that minus is left associative from this grammar. The operator minus is left associative. Now if you look at the production for T, T gives T plus F, I'll keep on giving t plus f until t can be resolved to f. So t gives t plus f, this t will again give t plus f, now this t I can give f. So if you look at this, what I've got is f plus f, and in this f plus f also I am applying the bracket first. The initial f plus f I am coupling together, and after that I am adding f. So if you see clearly, plus is left associative in this grammar. Now let us say I have an expression final string id minus id plus id. So how can I get this string from the grammar? How I will do that is id I will resolve to f, this id also I will resolve to f, and this f I will resolve to t. Now I can apply t plus f, t gives t plus f, which I have done here. Similarly, this id I will resolve to f, f I will resolve to t, t I will resolve to e. Now I can do e minus t, e gives e minus t, like in the first one. So essentially what happened here is, for id minus id plus id, what we did is we are applying the brackets in this way. Okay, we are adding the first ids together, and after that we are subtracting that from id. So clearly for id minus id plus id, we are doing the plus operation first, and after that we are doing the minus operation, which means plus has higher precedence in this grammar and minus has a lower precedence. Now based on this info, we will look at the question. We will look at the options. For option A, if you see, e gives e minus t or t. Now this is clearly left recursion. E gives e minus something, which this e I can keep on resolving to e, which will appear at the start. So this is left recursion. We haven't eliminated left recursion here, so A is wrong. If you look at B, e gives t e dash, that is fine. E dash gives minus t e dash or epsilon, that's fine. T gives t plus f or f. Now clearly t is giving t again, so this is again left recursion. T is giving t, this t can again give t, so t's will keep on appearing on the left side only. So this is also a left recursion, so this is also not the right answer. Now if you look at option D, it says that e gives tx or in parenthesis tx. Now this x I can resolve it to minus tx or plus tx or epsilon. See, for the x term I can simultaneously do minus t or plus t, which means minus or plus both can appear from x, meaning minus or x has the same precedence in this grammar. But clearly we know that in our grammar, minus has the lower precedence and plus has the higher precedence. So in this grammar both has the same precedence, so this is not equivalent to our grammar, so this is also wrong. C is the only option left, and that was the right answer. You can try generating strings from this grammar and then verify that all the strings that we get will be equivalent to this grammar only. C is the right answer. A system shares 9 tape drives. The current allocation and maximum requirement of tape drives for 3 processes are shown below. Process P1, P2, P3, current allocation 313, maximum requirement 765. Which of the following best describes the current state of the system? A. Safe, deadlocked. B. Safe, not deadlocked. C. Not safe, deadlocked. And D. Not safe, not deadlocked. So this is a very straightforward question from Banker's algorithm coming from operating systems topic. If you don't know Banker's algorithm for solving such questions regarding deadlocks, please refer to the video lectures for the same and learn that first. So for this question I will show you how to do this. In the question they have given us that there is 9 tape drives. So there are 9 resources that is shared by these 3 processes given here, and currently P1 has 3 of those, P2 has 1, P3 has 3, and they are asking if their maximum requirement of the resources is 765 respectively, then whether it is deadlocked, is it safe, etc. So based on this current allocation and maximum requirement information we have, we can find out what will be the future requirement of each of the processes. So for P1 it has 3 already, it will require 7 maximum, so in the future it can request up to 4. Similarly P2 has 1 and it has a maximum need of 6, so in the future it will request up to 5. Similarly P3 has currently 3, maximum is 5, so it can request up to 2 resources now. Now the available resources is, they have given that there is 9 tape drives in total. Currently 3 plus 1 plus 3, that is 7 resources have been allocated. So currently unallocated resources are available. Ones is 9 minus 3 plus 1 plus 3, that is 2. So we have 2 resources available. Now let us say if we can satisfy the need of the processes now. So if you look at the future needs, we have 2 unallocated resources, and P3 will require 2 more, meaning that I can satisfy P3 now. So I will assign these 2 more to P3, P3 will run, and then after that, after P3 is over, it will release all the resources, the ones which we assigned just now and the one which it already had. So it already had 3 plus 2 we assigned. So after running, it will release a total of 5 resources. Now we will have a total of 5 available. Now P1 only needs 4 more. I can satisfy P1 now. I will assign 4 of this to P1. P1 will run, and then after that it will be releasing 3 additional resources. So total I will have 5 plus 3, that is 8. Now I have 8, P2 only needs 5. Clearly I can satisfy P2 as well. I will give 5 to P2. P2 will run and then release all the resources. So this is safe. There is no chance of deadlock now. I can safely assign resources such that all of these 3 can finish executing. So this is safe and it is not deadlocked as well. So the answer is B, safe, not deadlocked. Consider a binary code that consists of only 4 valid code words as given below: 00000, 01011, 10101 and 11110. Let the minimum Hamming distance of the code be P and the maximum number of erroneous bits that can be corrected by the code be Q. Then the values of P and Q are, and we have been given 4 options. So this is a straightforward question coming from Hamming codes, that's coming from number systems topic in digital logic. So if you don't know Hamming codes and error correction etc., please refer to the video lectures to understand more about that. So for this question I will show you how to do it. So these are the 4 codes given that I have written here. These are the 4 valid codes in our system here. Now the Hamming distance between any 2 valid code will be the number of bits we need to change in order to change it from 1 to 2. So 00000 and 01011, if you consider, the number of bits I need to change in this to make it this will be, so here it is 0, here it is 0, I'll keep it just like that. Here it is 0 and 1, so 0 I need to change to 1, it will add 1, 0 and 0 is same, 1 I will need to change to 1 and 0 I will need to change to 1 and this 0 I will need to change to 1. Meaning I need to make changes in 3 bits in order to convert this code to this code. Now that is the Hamming distance between these 2 codes. Now I have written down all the 4 codes and I have drawn a graph here showing the Hamming distance between each of the codes. Okay. Now these are all numbers in the code. So the total Hamming distance for this entire code will be the minimum distance between any 2 valid numbers in the code. So if you see, the distances are 3 and 4 whenever we take 2 pairs from this. So the minimum would be 3 here. So the Hamming distance of the entire code will be given as 3, which means that P equal to 3. Now we have found out P. Now we need to calculate the maximum number of erroneous bits that can be corrected by a code. Now if the Hamming distance of a code is P, then the number of bits that can be corrected will be P minus 1 by 2. Now that I can apply directly here. So Hamming distance is 3, 3 minus 1 by 2 will be 1. So the value of Q for this question will be 1. We can only do correction for 1 bit. So the option will be P equal to 3 and Q equal to 1. Now how I got this formula, please refer to the video lectures to understand that more, but I will give a rough explanation here as well. So consider the code 00000. If I need to change it to code 01011, I need to make 3 bit changes. Now suppose that we know there will only be 1 bit errors at maximum. So there can be 0 bit errors in which we got a valid code only, there is no error, or at maximum 1 bit error. Let us say there won't be any 2 bit error in this. Then we can easily do error correction, because consider this number 00000. Let us suppose I make a 1 bit change here in this bit, and let us say it becomes 01000. So if I calculate the distance of this code with each of the numbers in our code given, then if you will see that only to 00000 the distance will be 1, and to all the other numbers the distance will be greater than or equal to 2, since it was only a 1 bit change. So if we know that it is a 1 bit error, we can definitely find out from which number we arrived at the erroneous number. So only for 1 bit I can do error correction just like that. Now suppose there can be 2 bit errors as well. Let us say A and C are two valid numbers in our code. With 1 bit I can say, let us say I can get x1 the number, and with 2 bit changes let us say I can get x2, and with 3 bit changes let us say I can get another valid number C here. So on changing A to C, if there are 2 bit errors, then from A I can get x2 also using 2 bit changes. From C I can get x2 using just 1 bit changes. So if I get an erroneous number like x2, I will see that using 1 bit change I can get C, using 2 bit change I can get A. So I can't say for sure which one it would be, whether it came from A or C, because we are assuming there can be a maximum of 2 bit errors. So if there can be 2 bit errors, we can't do error correction like this. There will be multiple numbers to which that erroneous number can match. So in this system we can only do 1 bit error correction. That's what given here, and A is the right answer. Consider two hosts X and Y connected by a single direct link of rate 10 raised to 6 bits per second. The distance between the two hosts is 10,000 km and the propagation speed along the link equals 2 into 10 raised to 8 meter per second. Host X sends a file of 50,000 bytes as one large message to host Y continuously. Let the transmission and propagation delays be P milliseconds and Q milliseconds respectively. Then the values of P and Q are, we have been given 4 options. So this is an easy question coming from computer network section. We have been given this connection details and we just need to find out the propagation delay and the transmission delay. So propagation delay given by Tp will be equal to total distance of the link divided by the velocity in the link. That will be equal to, distance was 10,000 km divided by 2 into 10 raised to 8 meter per second. That is 10 raised to 7 meter divided by 2 into 10 raised to 8 meter per second. Now that is equal to 50 millisecond. So propagation delay is 50 millisecond. Transmission delay will be L by B, where L is the length of the packet and B is the bandwidth of the link. That will be equal to 50,000 bytes divided by 10 raised to 6 bits per second. Now this byte I will convert to bit. Now that will be 5 into 10 raised to 4 into 8 bits divided by 10 raised to 6 bits per second. Now that will give us 40 by 100 per second. That's equal to 40 into 1000 divided by 100 millisecond. That is 400 millisecond. So transmission delay is 400, propagation delay is 50. They were asking transmission delay and propagation delay. Now that is 400, 50. Option D is the right answer. The pre-ordered traversal of a binary search tree is given by 12, 8, 6, 2, 7, 9, 10, 16, 15, 19, 17, 20. The post-ordered traversal of the tree is, and we have been given 4 options here. So this is a question from data structures regarding binary search tree and the pre-ordered traversal, in-order traversal, post-order traversal, etc. So what is post-order traversal? If we have a binary tree like this, A, B, C, what the pre-order traversal would do is, it will print the node A first and then it will traverse the left subtree and then it will traverse the right subtree. So if the tree is only this much, it will print A first and then B and then C. So this is pre-order traversal. In-order traversal means if the node is like this, first it will traverse the left subtree, then it will print the current node and then it will print the right subtree. So for this tree, in-order traversal will print B, A, C. And post-order traversal means it will traverse the left subtree first, then the right subtree, after that it will print the current node. So for this tree it will print B, C, A. So in the question they have only given us the post-order, the pre-order traversal of the tree. And one more information is given, it is a binary search tree. So based on these two information we need to find out the post-order traversal of the tree from the options given here. So we won't be doing the entire post-order traversal of the tree. We'll just look at the options and then we'll choose the best suited one. Okay, we don't need to find out the entire thing to answer this question. So we'll start. In pre-order traversal, the first node printed will be the root node. If it's a tree like this, it will print first the root node, after that it will print the left subtree and then the right subtree. So clearly in this 12 is the one that is being printed first. So clearly in our tree 12 will be the root node. So I'll put 12 here and then there will be a bunch of numbers to the left side and then a bunch of numbers to the right side. So if a tree is like this, 12 and then left and right, what will happen in the post order traversal? In the post order traversal, it will print the left subtree first, and then it will print the right subtree first, and then it will print the root node at the end. So 12 will be the last number printed in the post order traversal. But if you look at the option, A is saying 20 is the last number printed. So clearly A is wrong. Only B, C and D are printing 12 at the last. So we can eliminate option A. We only need to look at option B, C and D now. Now we look at the second information given in the question. It is a binary search tree, meaning all numbers less than 12 should appear to the left side of 12 and all numbers greater than 12 should appear to the right side of 12. Now in the question, if you see 8, 6, 2, 7 and 9 and 10 are less than 12, 16, 15, 19, 17, 20 are greater than 12, right? Which means that 8, 6, 2, 7, 9 and 10 will appear to the left side of 12, and 16, 15, 19, 17, 20 should appear to the right side of 12, meaning the left subtree of 12 will be made up of these numbers and the right subtree of 12 will be made up of these numbers. Now if you look, 8 is the second number printed. So what does that mean? The first number printed will be the root node 12, and then we will go to the left subtree. The second number printed will be the root node of the left subtree, so that is 8. Meaning 8 is the root node of the left subtree. So to the left, the immediate node would be 8. Similarly, we have 8, 6, 2, 7, 9 and 12 in the left subtree, and we have 16, 15, 19, 17 and 20 in the right subtree. So we will be printing the whole left subtree, that is 8, 6, 2, 7, 9 and 10. We will be printing up to this. After that, we will go to the pre-order traversal of the right subtree. So in the right subtree, which will be the first node printed? The first node printed would be the root node of the right subtree, and the first number is 16, which means that 16 is the root node of the right subtree, which that we can clearly say that here. So the left subtree will look like something like 16, and then some left subtree and then some right tree. Okay. Now let us look at the post order traversal of this tree. How will it look? It will print the left subtree, and then it will come to the right subtree. It will print this tree to the left of this, and then it will print this part to the right of this, and then it will print this node, and finally it will print this node. So the post order traversal will have the last node as 12, which we did earlier, and the second last node would be 16. Now if you look at the options, only B and C has the second last node at 16. D has the second last node as 19. So option D also we can eliminate. Now we know that to the right side of 12 we will have 16, 15, 19, 17 and 20, and the first node is 16 here. So this is again a binary search tree, meaning numbers less than 16 will appear to the left side of 16 and the numbers greater than 16 will appear to the right side of 16. The rest of the numbers are 15, 19, 17 and 20, which meaning 15 will appear to the left side of 16 and 19, 17 and 20 will appear to the right side of 16. Now again let us do the post order traversal. What it will do is, it will print this tree, it will come here, it will print the left side of this, that will be 15, and then it will print the right side of this node, that will be one of these three numbers, and then it will print 16, and then it will print 12. Meaning the last number printed in post order traversal will be 12, the second last number printed will be 16, and the third last number will be one number in the right subtree of 16. So right subtree of 16 has 19, 17 and 20. So one of these three numbers will be printed there. Now if you look at the options, option C is saying that 15 is the third last number printed. Now that will never happen. The third last number has to be one of these numbers, 19, 17 or 20. Now from the options, only 19 is the correct one, that's given in option B. Option C is saying 15, so option C is wrong. Option B is saying 19, so option B is the right answer here. We don't need to look further. We have already eliminated three options which will never happen, and the only one left is B. So you can try constructing the tree in similar manner and then verify that this itself will be the full thing given. But during gate you don't need to do it for the entire thing. Only once you eliminate three options you can give that B is the right answer. B is the answer here. Consider the C program fragment below, which is meant to divide x and y using repeated subtractions. The variables x, y, q and r are all unsigned int. While r greater than or equal to y, r equal to r minus y, q equal to q plus 1. This is the code. And which of the following conditions on the variables x, y, q and r before the execution of the fragment will ensure that the loop terminates in a satisfying condition x equal to y into q plus r. Now this is the code fragment given to us in order to do x divided by y using repeated subtraction. So I'll show you how to do that. What we want is to do x divided by y. Now how to do it using repeated subtractions is, initially let the quotient equal to 0, and while x is greater than or equal to y, we need to divide x with y. While x is greater than or equal to y, we'll subtract 1y from x, meaning x will become x minus y, and then we'll add 1 to quotient plus plus. So we'll keep on doing that until x becomes less than y, and finally whatever we have in x will be the remainder. So x would be equal to x. Remainder would be equal to x. Now if we do this, we will do x minus y, we will do x divided by y, and the quotient would be stored in this variable quotient we have here, and the remainder would be stored in this remainder variable we have here. And now we can write the condition that initially what we had in x would be equal to y into quotient plus remainder. This will satisfy. So this is the code for doing division of x with y. Now let us compare it with whatever code we have here. If you look here, you can see while r is greater than or equal to y, r equal to r minus y, q equal to q plus 1. So when you compare it with the code I have written here, you can clearly say that q will be the quotient here. That's what we are adding each time. Now the condition for quotient was that initially quotient should be equal to 0, only then the right one should be stored in q quotient. So quotient is q, and when we can write that q should be initially 0. That is one condition. Now in the while loop, the condition is r is greater than or equal to y. Now we were doing x's division with y, and the condition was x is greater than or equal to y. Now from this we can see that r should be equal to x. That is the second condition here. And also one more condition is that we are doing in the while loop x equal to x minus y. Now y should be greater than or equal to, y should be greater than 0, not equal to. Only if y is greater than 0, this loop will reduce x, and only if x is getting reduced, this will terminate eventually. If y is 0, it is just like division by 0, and this loop will keep on executing without any change, and that will result in an infinite loop. So one other condition is that y should be greater than 0. That's the third condition. Now let us look at the options here. If you look at C, that covers all the options: q equal to 0, r equal to x, and y greater than 0. So option C is the right answer. Consider the following C function: int fun, parameter int n. The function is int I j. For I equal to 1, I less than or equal to n, I plus plus. For j equal to 1, j less than n, j plus equal to I. Printf %d I j. The complexity of fun in terms of theta notation is, and we have been given 4 options. So we need to find out the time complexity of running this function with some n. Now let us see how to calculate that. So if you look at the function, I changes from 1 up to n in increments of 1. That is, initially I is 1, then I becomes 2, then I becomes 3, till I becomes n. That is the first for loop. So I will change from 1, 2, 3, etc. up to n. These are the values I will take. Now for each value of I, let us see what j will take. Now the loop for j is j equal to 1, j less than n, j plus equal to I. So j will start from 1 and j will grow till n in increments of I. Meaning if I is 1, initially j will be 1, then j will become 2, then j will become 3, etc. up to j becomes n. Meaning there will be n times the loop will run. So j will run n times. When I is 2, let us see what happens. J will be 1, then j will be j plus 2, j plus I was 2, so j will become j plus 2 equal to 3, then j will become j plus 2 equal to 5, up to j becomes n. So j increases in 2s up to n, which meaning that j can have n by 2 values, n by 2 different values here. So j will take n by 2 different values here. Now if I is 3, again j will start from 1, j will increment by 3, again j will increment by 3 up to n, meaning j will take n by 3 different values. Similarly, up to I becomes n, then j will take n by n different values. So for each I have written how many times j will run, the loop j will run, and each time in that loop for j there will be one printf statement. Now this printf statement will take only theta one time. So let us see how many times the entire printf statement will run. So when I is equal to 1, the loop for j will run n times, meaning n printf statement will be executed, so we will add n for that. Similarly, when I is 2, the loop will run n by 2 times, meaning n by 2 times the printf statement will run. So n plus n by 2 plus when I is 3 it will be n by 3, etc. When I is n, the loop will run n by n times, that is 1 time. So this is the number of times the printf statement will run, and that is the complexity also. So n plus n by 2 plus n by 3 up to n by n is the total complexity. This we can rewrite as n into 1 plus 1 by 2 plus 1 by 3 up to 1 by n. Now 1 plus 1 by 2 plus 1 by 3 up to 1 by n, there is no exact formula for this, but this will be roughly log n, meaning that the total complexity of our function will be theta of n log n. This is the answer, that is option C. Let delta denote the transition function and del cap denote the extended transition function of the epsilon NFA, whose transition table is given below. We have been given this transition table. Then del cap of Q2 ABA is, they have been given the 4 options here. So this is a question from theory of computation regarding NFA and epsilon NFA. So here we have been given the transition table for an epsilon NFA, including the transition for epsilons, and then A and B are the letters in the alphabet. So this is the transition table given below. Now they are asking to find out the extended transition function del cap, and we need to find out the del cap for ABA on Q2, which means that if you are in state Q2 and if you are seeing the string ABA, which all states we can finally reach, we need to find out del cap meaning for epsilon transition also we need to include. Now let us see how to do that. Now this is the NFA given for this transition table. Initially we have state Q0. In Q0, on seeing epsilon I will go to Q2, which I have given here. On epsilon I go to Q2. On A I go to Q1, given here. On B I go to Q0. From Q0 on B I go to the same state Q0 only. Now let us look at Q1. On epsilon I go to Q2. On A I go to Q2, so epsilon comma I will go to the same state Q2, and on B I go to Q3, which is given here. From Q2 on epsilon I go to Q0, we have a transition back to Q0. On A and B there is no transition, it's an NFA, so that is perfectly fine. In Q3 on epsilon or A we don't have any transition, only on B we will go to Q2, so this is the NFA. Now based on this, let us see what will happen when ABA appears when we are in state Q2. So in the state, currently we are in state Q2, okay, I have given it here. Now we need to find out del cap, which is the extended transition function. So whichever transition we can take using epsilon, that is which all state we can go using epsilon transition, that also we need to include. So currently we are in state Q2. If you see on epsilon we can go to Q0 as well. So I will write it like this here, Q0 as well. And on epsilon on Q0 I can go to Q2, but Q2 is already there. There are no other states which I can go using epsilon transition. So if you are at Q2, even before we start seeing the strings in ABA, even before we start seeing this, we can reach states Q0 from Q2 using the epsilon transition. So simultaneously we can be in state Q2 and Q0. Now let us say we are seeing the string A. Now on Q2 we'll take A transition, on Q0 also we'll take A's transition. So if you look on Q2 there is no A transition available, so we can't go anywhere. So this I will close it with a red cross. On Q0, on seeing A I can go to Q1. So Q1 is the current state now. Now let us see where all we can go using epsilon transitions. From Q1 with epsilon I can go to Q2, and on Q2 with epsilon I can go to Q0. There are no further state which I can go using epsilon transition. So after seeing A, I can be simultaneously in states Q1, Q2 or Q0. Again I will see the next alphabet, that is B. On Q0, on seeing B, I will go to Q0 only. Q2, on seeing B, there is no transition available. So from Q2 I can't go anywhere on seeing B. From Q1 on seeing B, I can go to Q3. So now Q0 and Q3 are the states now. But if you look from Q0 taking epsilon transition, I can simultaneously go to Q2 as well. There are no further epsilon transition which I can take. So currently the states are Q0, Q2 and Q3. Again we need to see the third letter, that is A. Q0 on A I can go to Q1. From Q2 on seeing A there is no transition, so this is closed here. Q3 on seeing A there is no more transition, so that's also closed here. So the final state will be Q1. But then we need to include the epsilon transitions as well. From Q1 I can take epsilon transition and go to Q2. From Q2 I can take epsilon transition and go to Q0 as well. There are no more epsilon transitions. So if I was in state Q2 initially, on seeing string ABA, I can finally end up in one of these three states, that is Q1, Q2 and Q0. Now we look at the options, Q0, Q1 and Q2, that is option C. Consider the following languages. L1 equals a power p such that p is a prime number. L2 equals a power n, b power m, c power 2m such that n greater than or equal to 0, m greater than or equal to 0. L3 equals a power n, b power n, c power 2n such that n greater than or equal to 0. L4 equals a power n, b power n such that n greater than or equal to 1. Which of the following are correct? And they are given 4 statements and they are asking us to choose the right option from A, B, C, D. So let's take a look at the languages first. The first language is a power p such that p is a prime number. Now this is not a context free language. Here we need to check that p is a prime number. That means we need to calculate for all the prime numbers and then compare it with that. So all this we can't do it with a push down automata. We need a Turing machine for doing calculations such that p is a prime number and all. So this is not a context free language. Now statement 1 says L1 is context free but not regular. So this statement is false. Now let's look at language 2, a power n, b power m, c power 2m such that n greater than or equal to 0, m greater than or equal to 0. Now this is context free language. We just keep on adding n to the stack, or even we don't even need to do that. We are not comparing a with anything. So we'll just ignore all the a's. When we see b's, add 2b each, and when we start seeing c, for each b we will be removing one c from the stack. So for example, let us say a square, b square, c4. This is the string. So a's we won't be adding to the stack. We just need compare and check that all a's are coming in. And after that, for each b we will be adding 2b to the stack, meaning I'll be adding bb for the first b, then bb for the second b. Now for each c I will pop one b from the stack. So there are 4 c's here and the stack is empty, meaning I can compare this equals half of this. I can do that comparison in this way. So this is a context free language clearly. Let's look at the statement. L2 is not context free. Now this is also false. L2 is a context free language. Third one, L3 is not context free but recursive. Let's look at the language. It says a power n, b power n, c power 2n. Now this is not a context free language, it's a context sensitive language. Here we need to compare for 3 variables. Now a and b and we can easily compare. B and C also we can compare, just like I shown in L2. But A, B and C, all these 3 together we can't do comparison using a single stack. So this is not a context free language. This is actually a context sensitive language. So L3 saying that it's not context free but recursive, that is correct. Now L4, a power n, b power n such that n is greater than or equal to 1. This is clearly a deterministic context free language. What we will do is same as we did here in the stack. I will keep on adding a's, and when I start seeing b's I will just pop off each a for a b scene, and at the end I will come check that the stack is empty. So this is a deterministic context free language. So this statement is true. So the right ones are 3 and 4. That is option D. Let LR be the language represented by regular expression R. Let LG be the language generated by a context-free grammar G. Let LM be the language accepted by a Turing machine M. Which of the following problems are undecidable? 1. Given a regular expression R and a string W, is W belonging to language of R? 2. Given a context-free grammar G, is language of G equal to null set? Given a context-free grammar G, is language of G equals to epsilon star for some alphabet epsilon? 4. Given a Turing machine M and a string W, is W belonging to language of M? Now, this is a question from theory of computation section regarding decidability and undecidability. Now, we have been given these 4 statements and we need to find out which of these problems are undecidable. Now, here I have given a few problems and whether it is decidable or undecidable for a set of languages. One is membership problem. Now, what is membership problem? Membership problem means given a string W, let us say, whether that belongs to the given grammar. That's membership problem. Now, let's say for regular grammars, if we have been given a string W, whether that belongs to a regular grammar, to check that is a decidable problem. How we do that is for every regular grammar we will have a finite automata. So we just need to run the given string in that finite automata and check whether it accepts or it rejects. So for regular grammars, membership problem is acceptable. For context-free grammars is decidable. For context-free grammars also, membership problem is decidable. How we do that is for every context-free grammar there will be push-down automata. Now we can just run the push-down automata with the string as input and check whether it accepts or rejects. Now for recursively enumerable languages, membership problem is undecidable. The reason for that is if we input a string to a Turing machine, it can either halt or it can not halt. It can go into a loop. So in that case, if it is accepted, we can definitely say that that string is accepted by the Turing machine. But if that string is not accepted by the Turing machine, it will go into reject state or it can go into a looping state. So we can't say for sure whether a string belongs to a recursively enumerable languages just by running it on that Turing machine. So membership problem is undecidable for recursively enumerable languages. Now the second is emptiness problem. Given a grammar, we need to find out whether the language of the grammar is an empty set. So for recursive languages, this is decidable. For context-free grammar also it is decidable. How we do that is from the starting state we can keep on eliminating all the unreachable states, etc. And similarly we can find out whether there will be at least one string generated by the grammar. So the exact proof you can refer to the video lecture and find out. So the emptiness problem for regular grammar, it is decidable. For context-free grammar, it is also decidable. For recursive enumerable languages, it is undecidable. Similarly, completeness problem. Completeness problem means given an alphabet epsilon, whether the language generated by the grammar equal to epsilon star. That's what completeness problem specifies. So again, for regular grammars it is decidable, for context-free grammar it is undecidable, and for recursively enumerable languages it is undecidable. Now the proofs of all of these and similar, there are many other problems similar to this. All of that you can find out in the video lectures. There's a table given at the end of theory of computation section which outlines all such problems and decidability of the problems for regular, context-free, recursive, enumerable, and also other types of grammar such as recursive, deterministic, context-free, context-sensitive, etc. So there's a large table outlining many similar problems given at the end of theory of computation section. So please refer to that for understanding how we got this, and also the proofs of this you can see in the video lectures. So based on this information, we look at the options. Statement 1, given a regular expression R and string W, whether W belongs to L of R. That is membership problem for regular grammar. That is decidable. Given a context-free grammar G, is L of G equal to 5. Now this is nothing but the emptiness problem for context-free grammar, which is decidable as I have given here. So this is also decidable. 3, given a context-free grammar G, is L of G equal to epsilon star for some alphabet epsilon. This is completeness problem for context-free grammar. Now that is, as I have given here, completeness problem for context-free grammar is not decidable. So this is not decidable. 4, given a Turing machine M and a string W, is W belong to language of the Turing machine. Now this is membership problem. Membership problem for recursively enumerable languages is undecidable. They have just given a Turing machine M. That means a recursive enumerable language, and membership problem for that is undecidable. So 3 and 4 are undecidable here, 1 and 2 are decidable. And in the question they were asking which of the following problems were undecidable. So the answer is 3 and 4. Option D. The next state of a 2-bit saturating up counter is given below. Q1, Q0, Q1 plus, Q0 plus. 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 1. The counter is built as a synchronous sequential circuit using T flip-flops. The expression for T1 and T0 are, and we have been given 4 options. So this is a question from sequential circuits in digital logic design. So here they are saying that we have a 2-bit up counter designed using 2 T flip-flops, and they have given the transition states also for the counter, and they are asking us to find out the expression for T1 and T0. Expression for T1 and T0 means that input to the T flip-flop for Q1, that is T1, and the input to the T flip-flop having Q0 is T0. And they are asking us to find out the expression for that. So if you see, this is T flip-flop's excitation table. The property of T flip-flop is that if we input 0 to it, it will remain in the same state, and if you are inputting 1, that state will toggle. So let us look at the excitation table. T flip-flop changing state from 0 to 0, then what is the input for that? If the state is changing from 0 to 0, meaning the state is remaining same, meaning the input should be 0. If the state is changing from 0 to 1, that's a toggle operation, meaning the input should be 1. If the state is changing from 1 to 0, that's again a toggle operation, so the input should be 1. If the state is changing from 1 to 1, meaning the state is remaining same, so the input will be 0. Now let's look at the table given in question. Q1, Q0, when it is 0, 0, it goes to 0, 1 state. Q1 plus, Q0 plus is the next state. Okay. So Q1 is changing from here to this part, and Q0 is changing from here to this part. So let us look at Q1. Q1 changing from this to this, and let us see what the input should be for this change to happen. So here Q1 is changing from 0 to 0, meaning what should be the input? Just look at the excitation table. When a T flip-flop changes from 0 to 0, the input should be 0, meaning the input T1 should be 0. Okay. Similarly here Q1 is changing from 0 to 1. When does that happen? That's a toggle operation, meaning the input should be 1. The same thing I have given the excitation table as well, 0 to 1 meaning 1. Similarly here it's changing from 1 to 1, meaning it should be a 0. Changing from 1 to 1, meaning again it should be a 0. So this should be the input to the first T flip-flop whose output is Q1. Similarly, let's look at Q0. Q0 changing from Q0 to Q0 plus. The change, first one is 0 to 1, meaning the input T0 should be 1. Next is 1 to 0, meaning the input T0 should be 1. Now 0 to 1, meaning the input should be 1. 1 to 1, now the state is remaining same, meaning the input should be 0. Now if you take a look, this is Q1, Q0, and T1 and T0 is the input to the T flip-flops, right? We obtain this input using some combination of Q1 and Q0. See how it happens is we have 2 T flip-flops like this. Let us call this one T1 having output Q1, and the second one will be T0 having output Q0. Let us say now Q1 and Q0, some combination of this is what we will give as input to T1. Similarly Q1 and Q0, some combination of this is what we will be giving as input to T0 as well. Now we know what T1 and T0 should be, what the input should be, we know the values from here. Now we need to find out how we can obtain these values using some combination of Q1 and Q0. So if you see, if you look at T1, only here the second one it is 1, for the rest all it should be 0. Meaning for this value, when Q1 is 1 and Q1 is 0, it is 1, for all it should be 0. This is nothing but the expression Q1 complement into Q0. So if you look Q1 complement into Q0, only for 0, 1 it will be 1. For the rest all 3 it will be 0. Meaning T1 is Q1 complement Q0. Now if you look at T0, for the first 3 it should be 1, and only for the last one it should be 0. So that will be an AND operation. Only here it is 0, meaning only for Q1 complement, Q0 complement it will be 0. For all the others it should be 1. I mean only for Q1 and Q0 it should be 0. For the others it should be 1. So T0 I can write it as Q1 complement plus Q0 complement. This will be 0 only when Q1 is 1 and Q0 is 1. For all the other combinations it will be 1. So this is the expression for T1 and T0. Now we look at the options. That is option B. So this is a question from C programming section. The question was pretty large, so I have written it a bit small, so I will read it out if something is not visible for you. Consider the following C program. Assume swap ampersand x ampersand y exchanges the contents of x and y. And the program is this: int main, int array equals 3, 5, 1, 4, 6, 2, int done equal to 0, int I. Then we have a while loop. While done equal to 0, done equal to 1. For I equal to 0, I less than or equal to 4, I plus plus. If array of I less than array of I plus 1, swap array of I and array of I plus 1, done equal to 0. Then there is one more for loop. For I equal to 5, I greater or equal to 1, I minus minus. If array of I greater than array of I minus 1, swap array of I and array of I minus 1, done equal to 0. These two for loops come within this while loop. And at the end we are printing array of 3, printf array of 3. The output of the program is dash. So they have given us this particular program. We are assigning this array and we are running the while loop on this array, and they want to find out at the end what the value of array of 3 would be. So let's look at this while loop. The first for loop is for I equal to 0 to 4, I plus plus. If array of I less than array of I plus 1, swap array of I and array of I plus 1. So this array has 6 elements, so it ranges from array of 0 up to array of 5, and in the loop it's doing for I equal to 0 to 4, if array of I less than array of I plus 1, we need to swap these two. So this sweep happens from the start to the end of the array, and inside what we are doing is if any element is less than the next element, then we will be swapping those two. And the exact same thing is happening in this for loop as well. For I equal to 5, I greater or equal to 1, I minus minus. If array of I greater than array of I minus 1, swap array of I and array of I minus 1. So here from the start up to end we were doing if array of I was less than array of I plus 1, we will swap it. The exact same thing we are doing here, only that now the iteration is from the end of the array to the start of the array, and we are doing swapping. If array of I is greater than array of I minus 1, we are swapping those two there. So if you look at this code, this is exactly the code for bubble sort, only that it is not that efficient. In each iteration we are iterating the entire array instead of excluding the part where we are sorted already, but that's fine. Anyway, what it does is it is doing bubble sort only for this array, and we are keeping on sorting until no more swap operation happens, meaning that array is sorted. And also if you look, we are swapping if array of I is less than array of I plus 1. That means this sorting happens in descending order. So you can try this out in the array and you can see that it sorts the array in descending order. So at the end the array will look like this: 6, 5, 4, 3, 2, 1. This is what happens if we sort the array in descending order. And we are printing array of 3. So this is array of 0, this is array of 1, this is array of 2, this is array of 3. Array of 3 is 3. So the output is 3. Two transactions T1 and T2 are given as T1 R1 of x, W1 of x, R1 of y, W1 of y, and T2 R2 of y, W2 of y, R2 of z, W2 of z, where Ri of v denotes a read operation by transaction Ti on a variable v, and Wi of v denotes a write operation by transaction Ti on a variable v. The total number of conflict serializable schedules that can be formed by T1 and T2 is dash. So this is a question coming from DBMS topics regarding transactions. In this question they are asking us about conflict serializability. So if you don't understand what conflict serializability means, please refer to the video lecture on the topic before trying to solve this question. So let's take a look at this here. So transaction T1 and T2 I have written here like this for understanding it better. So T1 has read of x, write of x, read of y, and then write of y. It's reading x, writing x, after that reading y, it's writing y. Similarly T2 has reading y, writing y, after that reading Z, writing Z. So they are asking us about conflict serializability. So conflict serializability, any conflict occurs when two transactions are either reading and writing on the same data object. So if you look at here, T1 is reading and writing X, after that reading and writing Y. Similarly, T2 is reading and writing on Y, after that reading and writing on Z. So if you see, data item X is operated upon only by T1 and data item Z is operated upon only by T2. So the common data item is Y only between T1 and T2. So we only need to worry about conflict serializability for the data item Y. Now for two transactions T1 and T2, there are two conflict serializable schedules possible. One is T1 and T2 and second one is T2, after that T1. So we'll look at the first one, the first serial schedule, that is T1, T2. Now how many ways are there in which we can write these operations such that T1 and T2 is conflict serializable to the serial schedule T1 and then T2. So if it should be conflict serializable to T1 and then T2, the conflict objects or the conflict operation should appear in the same order in our new schedule. So in T1 and T2, the conflict operation, which is read of Y, write of Y, then read of Y, write of Y, will appear in this order only. That is, the first transaction reads Y, then writes Y, and after that only this should appear. So the second transaction reads Y and then writes Y. So these four operations should appear in this order in a schedule that is conflict serializable to the serial schedule T1 and then T2. So if these four should appear in this order, let's try to assign the rest of the operations to this schedule. So first read 1 of Y and then write 1 of Y should appear. So if you look at T1 here, read 1 of Y, write 1 of Y appears here, and before that only read of X and write of X happens. So before this, read 1 of X and write 1 of X should happen. Similarly, read 2 of Y, write 2 of Y is appearing here. That is, read 2 of Y, write 2 of Y. After that only read 2 of Z and write 2 of Z should appear. Meaning read 2 of Z and write 2 of Z should appear after this. So meaning there is only one way of doing it. There is only one transaction which will have these four in this order. That is, read 1 of X, write 1 of X, read 1 of Y, write 1 of Y, read 2 of Y, write 2 of Y, read 2 of Z, write 2 of Z. Which is same as the serial schedule T1, T2 only. Now this has only one schedule possible. Now let's look at the other serial schedule, that is T2 and then T1. So if it appears like this, T2 and then T1, which means that read 2 of Y and write 2 of Y should appear here, and after that only read 1 of Y and write 1 of Y should appear. So if we assign these four like this, let us try to assign the rest of the operations and let us see how many possibilities are there. So read 2 of Y, write 2 of Y appears here, meaning after this read 2 of Z and write 2 of Z should appear. Similarly, read 1 of Y, write 1 of Y appears here, meaning that only after this should read 1 of X and write 1 of X should appear. So let us try to assign first read 2 of Z and write 2 of Z to this, and after that we will try to assign read 1 of X and write 1 of X, and then we will count all the possibilities. Okay. So initially I will write these four. Now the order of these four should not change, meaning read 2 of Y, write 2 of Y, and after that read 1 of Y and write 1 of Y. So these four should follow this particular order only, and after that we will be trying to assign read 2 of Z and write 2 of Z to the gaps here. So how many gaps are there if I assign these four in this order? Read 2 of Z and write 2 of Z should appear on after this only. So we will start from here. This is one gap. We can put both of them here. This is another gap between read 1 of Y and write 1 of Y. We can put both of them here. And there is one more gap, that is after this 2. So read 2 of Z and write 2 of Z. I can put both of them in this gap as well. So we have 3 gaps here. Let us try how to assign these 2 items in those 3 gaps. One is that we assign both of them to the gap between this and this. So we should start only after this. Okay. So we'll assign these 2 in this gap. That is one possibility. Another possibility is we'll assign read 2 of Z to this gap. Write 2 of Z should appear after this. And write 2 of Z I will assign to this gap between read 1 of Y and write 1 of Y. The third possibility is read 2 of Z I will keep here only, and write 2 of Z I will assign to this gap, which is what I have written here. That is after these 2 I am assigning write 2 of Z. Similarly, for this part, there is the other possibility is that we assign nothing to this gap. We assign 1 to this gap and the other one to this gap. That's what I have given here. Read 2 of y, write 2 of y, read 1 of y. These three I keep it here. The first one I assign to this gap, that is read 2 of z, and the second one I assign after this. There was one more way to do it, keeping read 2 of z here, that is we keep read 2 of z here, write 2 of z here. I could have assigned to this gap, and after that I do write 1 of y. And the final way of doing it is both of this I assign to this gap, then meaning read 2 of y, write 2 of y, read 1 of y, write 1 of y, and after that I assign read 2 of z and write 2 of z. So these are the 6 ways in which I can assign these two in these 3 gaps. Now our task is not over. We need to assign r1 of x and r write 1 of x as well. So in each of these, if you take a look here, read 1 of x and write 1 of x should appear before read 1 of y and write 1 of y. So let's take the first one here. So before read 1 of y and write 1 of y, we need to assign read 2 of z and write 2 of z. So there are 2 items here. And how many gaps are there? This is one gap. This is another gap. This is another gap. This is another gap. This is another gap. Okay. There are 5 gaps here. And then we need to assign 2 items in this order. So if you count, there are 15 ways of doing that. I'll show you how. One is I assign both here. That is one possibility. Or I assign one here and then second one here. Or I assign one here and the third one here. Or I assign one here and the fourth one here. Or I assign one here and the fifth one here. So an easy way of counting it is just take a look at it like this. The left one, if I assign to the first gap, then there are 5 gaps possible. 5 gaps available to assign the second one. So if the first one I assign to the first gap, there are 5 gaps left, meaning 5 series we get. If the first one I assign to the second gap, then for the second one I have 4 gaps left. 1, 2, 3 and 4, because the second one should appear to the right side of this one, right? So I can't put the second one in this gap. So if you put the first one here, there are 1, 2, 3, 4 gaps available for the second one, which will add another 4. Similarly, if I put this one in this gap, the third gap, I have 3 gaps left to put the second one, meaning it will add 3 additional series. If I assign the first one to this gap, there will be 2 gaps left to assign the second one, that will add 2. If I assign the first one to this gap, there is only one more gap left to add the last one, so that will add 1. Meaning there are 15 possibilities. So if there are 5 gaps here, there are 15 ways of assigning these two to the gaps. Similarly, let us take a look at this one. If you take a look at this one, we need to assign to the left side of r1 of y. There are 1, 2, 3, 4. You can do counting similarly, so you will find that there are 10 ways of assigning this. Just like I did here, there are 10 ways of assigning this. If you look at this one, there are 1, 2, 3, 4 gaps available, meaning again 10 ways of assigning. If you look here, there are 3 gaps available, that will be 6 ways of assigning. Here there are 3 gaps available, again that is 6 ways of assigning. Here also there are 3 gaps available, that's again 6 ways of assigning R1 and W1X. Now we have assigned everything, let us count. This is 15 plus 10 plus 10 plus 6 plus 6 plus 6. If you add everything, you will get a total of 53. So there are 53 schedules possible, which is conflict serializable to the serial schedule T2, T1. Similarly, for T1, T2 there was one more possible. So the total is 53 plus 1, that is 54. 54 is the answer to this question. The read access times and hit ratios for different caches in a memory hierarchy are as given below. I cache, D cache, L2 cache, and the read access time and hit ratios are given in the table. The read access time of main memory is 90 nanoseconds. Assume that the caches use referred word first read policy and the write back policy. Assume that all the caches are direct mapped caches. Assume that the dirty bit is always 0 for all the blocks in the caches. In execution of a program, 60% of memory reads are for instruction fetch and 40% are for operand fetch. the average read access time in nanoseconds is. So this is a question coming from computer organization regarding caches. Here they have given two caches, I cache and D cache, and also there is another L2 cache. So this is L1 L2 cache hierarchy. Here all the instructions will look at I cache and then it will look at L2 cache and then it will look at main memory. Similarly for data it will look at D cache first and then L2 cache and then main memory. A lot of data is given here, most of which is not needed for us to answer the question. So for L1 L2 cache, the average memory access time can be written as the L1 cache's access time plus miss ratio of L1 cache into L2 cache's access time plus miss ratio of L2 cache into main memory access time. So this is the equation for average memory access time when we have two L1 L2 caches. Now let us look at the average access time for information cache and data cache. For I cache, following the formula, I will write I cache time, that is 2, plus miss ratio of I cache is 0.2, that's given in the question. Hit ratio is 0.8, meaning miss ratio is 0.2, into access time of L2 cache is 8, plus miss ratio of L2 cache, that is 0.1, again which I got that from the question only. 0.1 into main memory access time is 90, that's also given in the question. So the total would be 2 plus 0.2 into 17, that is 2 plus 3.4, that is 5.4 nanoseconds. That is the average access time for I cache. Now for the D cache, similarly we will do the average access time, that is T of D we will call it, that's equal to 2 plus, that's D cache access time plus D cache miss ratio into L2 cache access time plus L2 cache miss ratio into main memory access time, that is 2 plus 0.1 into 17, that is 3.7. Now let us find out the average memory access time for these two. In the question it's given that 60% of the memory reads are for instruction fetch and 40% are for memory operand fetch. So instruction fetch meaning I cache and memory operand fetch means D cache. So 60% of the operation accesses come to I cache and 40% come to D cache, meaning the average would be, time average would be 0.6 into access time for Ti plus 0.4 into Td, that is access time for D cache, that is 0.6 into 5.4 plus 0.4 into 3.7, that is 4.72. 4.72 is the answer. Consider the following table named top scorer. We have been given this table having 3 columns, player, country and goals, and this data here. And consider the following SQL query. Select ta.player from top scorer as ta, where ta.goals greater than all of. Select tb.goals from top scorer as tb, where tb.country equal to Spain. And ta.goals greater than any of select tc.goals from top scorer as tc, where country equals Germany. So this is a question coming from SQL. This is a very easy question. We just need to know the concept of all and any in order to answer this question. So let's look at this particular query. What does this do? Select tb.goals from top scorer as tb, where tb.country equal to Spain. So it is returning goals where country is equal to Spain. But if you look at the table, there is not a single country having Spain, which meaning that this query will be returning a null set. It won't be returning anything. Now let's look at this query. Select tc.goals from top scorer as tc, where country equal to Germany. This is returning the goals of players having country as Germany. So this will return Germany is here 16, 14, 11 and 2 more Germany is here 10, 10. So it will return this table, that is 16, 14, 11, 10 and 10. Now with this info, let us look at the full query. Select ta.player from top scorer as ta, where ta.goals greater than all of what we got here and ta.goals greater than any of what we got here. So ta.goals greater than all of a null set would be true. Greater than all will always be true for a null set. So this will always return true for whatever tuples we select from top scorer. Now in this part, ta.goals greater than any of this table. Now when we do greater than any, you can see that this table has 16, 14, 11, 10 or 10, meaning this row returned should have goals greater than any of these goals listed below. So greater than any of these meaning the goal should be greater than 10 at least. So this will return to, this part will return true if goal is greater than 10. If goal is greater than 10, then this part will be true. So greater than any will be true. So let's look at the table and see how many players have goals greater than 10. There is 1, 2, 3, 4, 5, 6, 7. There are 7 players having goals greater than 10. So select TA dot player will return 7 rows. 7 is the answer. If the ordinary generating function of a sequence n to infinity is 1 plus z by 1 minus z the whole cube, then a3 minus a0 is. So this is a question from engineering mathematics regarding generating functions for sequences. So in the sequence they have given this closed form expression for the sequence. We need to convert it to a form such that a0 plus a1x plus a2x square plus a3x cube, etc. So we need to convert this to that form, and from there we need to get the coefficients of a3 and a0 and then print what is the value of a3 minus a0. So to answer that you need to know this combinatorial sequence. 1 minus x the whole raised to minus n, you need to know the expansion of this. 1 minus x the whole raised to minus n would be 1 plus nc1x plus n plus 1 c2 x square plus n plus 2 c3 x cube, etc. So if n is minus 3, I can rewrite it as 1 minus x the whole raised to minus 3 would be 1 plus 3x plus 6x square plus 10x cube plus etc. So now we can try to answer the question. 1 plus z by 1 minus z the whole cube, we can rewrite it as 1 plus z into 1 minus z the whole raised to minus 3. That is 1 plus z into this part. Using this sequence I will rewrite it as 1 plus 3z plus 6z square plus 10z cube, etc. Now I will multiply this with 1 plus z. If I multiply this sequence with 1, I will get the same sequence 1 plus 3z plus 6x square plus 10z cube, etc. And if I multiply it with z, I will get z plus 3z square plus 6z cube plus 10z raised to 4, etc. Now we will add these two. I will get 1 plus 3z and z I can add. I will get 4z plus 6z square and 3z square I can add. I will get 9z square plus 10z cube and 6z cube I can add. I will get 16z cube, etc. Now we have got this in the same format as a0 plus a1z plus a2z square plus a3z cube, etc. This is the generating function of the sequence given. Now I can easily write a3 minus a0, that will be 16 minus 1, that will be equal to 15. 15 is the answer. If a random variable x has Poisson distribution with mean 5, then the expression expectation of x plus 2 the whole square equals dash. So this is a question from probability theory regarding Poisson distributions. If you don't know about Poisson distribution, please learn the properties of that first before answering the question here. So let us try to find out what the value of expectation of x plus 2 square is. Expectation of x plus 2 square equal to expectation of x square plus 4x plus 4. This I got just by expanding x plus 2 the whole square. Now this I can split and write as expectation of x square plus 4 into expectation of x plus expectation of 4. Now expectation of 4 will be 4 only since it's a constant. Expectation of x is nothing but mean of the distribution. This was given in the question. Now expectation of x square, we don't know what that will be. That's what we need to find here. Now for variance, the formula of variance would be variance equal to expectation of x square minus expectation of x the whole square. And in Poisson distribution, mean and variance would be the same. That's a property of Poisson distributions. Which means that this formula I can rewrite it as variance equal to 5. It was given in the question. 5 equal to expectation of x square minus expectation of x the whole square. Now expectation of x is mean only, that is 5. 5 square I have written here. That's equal to expectation of x square minus 25. Which means that expectation of x square is 30. Now with this value we can substitute the values here and find out the answer. Expectation of x plus 2 the whole square equal to expectation of x square, that is 30, plus 4 into expectation of x, that is 4 into 5, plus expectation of 4, that is 4 only. That's equal to 30 plus 20 plus 4, that is 54. 54 is the answer. In a B plus tree, if the search key value is 8 bytes long, the block size is 512 bytes and the block pointer is 2 bytes, then the maximum order of the B plus tree is dash. So this is a question coming from DBMS regarding B plus trees. We have been given a block in a B plus tree and they are saying the search key value is 8 bytes and the block size is 2 bytes. If that's the case, what the maximum order of the B plus tree is, that's what we need to find out here. So consider a sample B plus tree of order 4. A B plus tree of order 4 will mean that it has a maximum of 4 children. It can have up to 4 children. So the internal node of such a B plus tree will look like this. There will be 4 children, meaning there will be 4 block pointers like this, and in between there will be key values. So if there are 4 children, that means there can be maximum 4 minus 1, that is 3 key values here. So based on this, we will make a general formula. For a B plus tree of order n, there will be n block pointers and n minus 1 key values in an internal node. Now based on this info, we will look at the question. So in the question, the block size is 512 bytes, which means for n block pointers and n minus 1 key values, the total size should be less than or equal to 512. So each block has 2 bytes, each block pointer has 2 bytes, meaning n into 2 plus there can be n minus 1 keys, n minus 1 into each key value is 8 byte long into 8 is less than or equal to 512. On solving this, we will see that 10n less than or equal to 520 or n is less than or equal to 52. So the maximum order of such a tree is 52. That's the answer. A message is made up entirely of characters from the set x equals p, q, r, s, t. The table of probabilities for each of the characters is shown below. For character p has probability of 0.22, q 0.34, r 0.17, s 0.19 and t 0.08. If a message of 100 characters over x is encoded using Huffman coding, then the expected length of the encoded message in bits is. So this is a standard question from algorithm section regarding Huffman coding. So what Huffman coding does is, for each of the characters it will give a unique binary encoding, and then the question is asking us, once that is done, what would be the expected length of the message having 100 characters in total. So the algorithm for Huffman coding is this. The probabilities we will write down in ascending order, and then we will consider these 5 as 5 nodes in a tree, and then we will choose the 2 nodes having the smallest probabilities each, and then we will merge those and create a new node, and that node will have the probability as the sum of the probabilities of these 2 nodes. I will show you how to do that here. These are the 5 probabilities written in ascending order. So if you see 0.08 and 0.17 are the smallest 2, we will combine these 2 and create a new node which will have the probability of 0.17 plus 0.08, that will be 0.25. That's what I have written here. Now initially there were 5 nodes. After merging 2, I will get 4 nodes. The probabilities are 0.19, 0.22, 0.25 I got by merging these 2, and 0.34. Now these are the smallest 2. I will merge these 2, which will give me 0.41 probability. Again the smallest 2 are 0.25 and 0.34. I will merge these 2, which will give me 0.41 and 0.59. On merging these 2, I will get the root node having probability of 1. So the same thing I will show you in a tree form. So initially these were the probabilities 0.19, 0.22, 0.08, 0.17 and 0.34. Like the procedure here, we have initially merged 0.08 and 0.17. That's what I did here. Similarly, whatever I did here, I have just written that in a tree form. And finally, this is the tree that I will get. 0.08 and 0.17 was merged together to get this. This and this was merged together to get this. This and this was merged together to get this. These 2 were merged to get the final root node having probability 1. Now this was node S, this was P, this was T, this was R and this was Q. Now the Huffman encoding for each of the characters is whatever binary sequence I have written here on the edge. So how I got this is that if a node has 2 children, then on each of the edge we will be writing 0 and 1 each. For example, this node has these 2 as children, so I will, on this edge I can write 0 and this edge I can write 1, or on this edge I can write 1 and this edge I can write 0. Anyway it is fine, but we will be having 1 0 and 1 node to each of the edges of the children. That way I filled it with 0s and 1. This is 0, this is 1, 0 1, 0 1, 0 1, like that. So the unique encoding of each character is the sequence of 0s or 1 starting from root node. So for S it is 0 0, for P it is 0 1, for T it is 1 0 0, for R it is 1 0 1, and for Q it is 1 1. So these are the encodings for each of these characters. Now we need to find out what the expected length of the encoded message in bits is. So in the question it is given there's a total of 100 characters. So if you multiply each of the probability with 100, you will see that in total it will give us 100 only when you take the sum of all this. Meaning if there are 100 characters, the expectation is that there will be 22 P's, 34 Q's, 17 R's, 19 S's and 8 T's. Now if that is the case, we will find out what the expected length would be. There are 19 S's into length of S is 0, 0, that is 2. So 19 into 2, which gives 38. There are 22 P's I have written here, and the length of P is 0, 1, that is 2. That's equal to 44. Similarly, for each of the characters I have written the same, and once you take the sum of all this, you will get 225. This is the expected length of the message. 225 is the answer. Consider a set of processes with arrival time, CPU burst time and priority. 0 is the highest, shown below. None of the processes have IO burst time. So we are given this table of processes P1 to P5 with arrival time, burst time and the corresponding priority. The average waiting time of all the processes using preemptive priority scheduling algorithm is. So this is a question from operating system regarding process scheduling. So here they are saying the scheduler used this preemptive priority scheduling algorithm. So preemptive priority scheduling means while a process is running, if another process having a priority greater than that comes in, at that time that running process would be preempted and the higher priority process would be given the CPU. So let us try to see how the scheduler will proceed. At time 0 only P1 is there, so we will start running with P1. At time 2 P4 will arrive. Now if you see, P1 has priority 2 and P4 has priority 1. In the question it was given that 0 is the highest priority. So meaning 1 is higher priority than 2. So we will preempt P1 and we will start running P4. So at time 2 P4 will start running. At time 5 P2 arrives and P2 has a priority of 0. 0 is the highest. So at time 5 P2 will start running. So if you look at the processes, P2 has the highest priority. No other process has a priority higher than P2. So P2 will keep on running uninterrupted till its burst time is over. So P2 started running at 5. It had a burst time of 28. So it will keep on running for 28 more cycles. So that is 5 plus 28. So P2 will keep running till 33. At this point P2 will be over. Now at 33, when the time is 33, you can see P3 and P5 both will have arrived by now. So we can just look in the processes and choose the highest priority process and just run that. So P2 is over. After that, the process with the highest priority is P4 having priority 1. So we'll start running P4. So if you see, P4 already ran from 2 to 5, that is for 3 milliseconds, and total burst time is 10. So P4 will need to run an additional 7 milliseconds. 3 already we completed. Total is 10. So 10 minus 3, 7 additionally it needs to run. So from 33 to 33 plus 7, P4 will run. That is up to 40. By this time P4 is over. We'll choose the next process with the highest priority. That is P1 having priority 2. So we'll start running P1. P1 will keep on running till 49. Because P1 already ran for 2 milliseconds, total was 11. So we needed 9 additional. So P1 will keep running till 49. After that, the process with the next highest priority is P3. P3 will run for 2 milliseconds. So 49 to 51, P3 will run. After that, P5 will run. P5 had the lowest priority. Now we will run P5 for 16 milliseconds. So starting from 51, for 16 milliseconds it will run, meaning till 67, P5 will run. Now let us calculate the waiting time for each of the processes. Waiting time of a process is given by the formula completion time minus arrival time minus the burst time. So completion time minus arrival time is the total turnaround time of the process. Turnaround time minus the burst time gives the waiting time of that process. So for P1 completed at 49, P1 arrived at 0. So turnaround time is 49 minus 0, and P1 had a burst time of 11. So this minus 11 gives 38. Similarly, I have calculated the waiting time for P2, P3, P4 and P5 based on this table and whatever value I can see in the chart drawn here. So average waiting time is 38 plus 0 plus 37 plus 28 plus 42 divided by 5. That will give you 29. 29 is the answer. If the characteristic polynomial of a 3 by 3 matrix M over R, the set of real numbers, is lambda cube minus 4 lambda square plus a lambda plus 30, a belongs to R, and one eigenvalue of M is 2, then the largest among the absolute values of the eigenvalues of M is dash. So this is a straightforward question coming from linear algebra. Here we have been given the characteristic equation of a 3 by 3 matrix M. So it's an equation of degree 3, meaning it will have the roots of this equation, there will be 3 values, and they have given that one of the roots is 2. One of the eigenvalue of M is 2, meaning on lambda, on substituting 2, we will get 0. Then the largest among the absolute values of the eigenvalues of M is dash. So how to solve this is, we will write the characteristic equation lambda cube minus 4 lambda square plus a lambda plus 30 equal to 0, and they have said that one of the roots of this equation is 2. So we will substitute 2 here. Now that will become 2 cube minus 4 into 2 square plus a into 2 plus 30 equal to 0, which is 8 minus 16 plus 2a plus 30 equal to 0. On solving this, we will get that a equal to minus 1. Now I can put the value of a in this equation. Now I will get lambda cube minus 4 lambda square minus 11 lambda plus 30 equal to 0. Lambda minus 2 I will take out as a factor because we know 2 is a root of this equation. So it will be lambda minus 2 into lambda square minus 2 lambda minus 15. That is nothing but lambda minus 2 into lambda minus 5 into lambda plus 3 equal to 0. So the value of lambda is 2, minus 3 and 5, meaning the eigenvalues of the matrix given here is 2, minus 3 and 5. In the question they were asking largest among the absolute values of eigenvalues of M. So the absolute values of eigenvalues of this is 2, 3 and 5, and the largest among that is 5. So 5 is the answer to this question. Consider a machine with a byte addressable main memory of 2 power 32 bytes divided into blocks of 32 bytes. Assume that a direct mapped cache having 512 cache lines is used with this machine. The size of the tag field in bits is dash. So this is a straightforward question coming from computer organization section regarding direct mapped cache. So the information we have is the main memory size is 2 power 32 bytes and it is byte addressable. It's given there. It's byte addressable. Okay. So the main memory is 2 power 32 bytes. Cache lines there are 512, which we can write as 2 power 9. The block size is 32 bytes, which we can write as 2 power 5 bytes. So if we take the physical address, we can divide that into 3 parts. One is the tag field, and the second is the cache line number, and the final part is block offset. So if you see, block size is 2 power 5 bytes, meaning block offset will need 5 bits. Similarly, the cache line is 512, that is 2 power 9. Now that will need 9 bits. The rest of the address will be the tag field. So the total size is 32, which was given in the question. Main memory size is 2 power 32 bytes. Now we can easily calculate tag field. Tag field size will be total main memory size, that is 32, minus cache line number plus block offset, that is 9 plus 5. That will be 32 minus 14 equal to 18. 18 is the answer to this question. This is also a C programming question. Here we have been given this code snippet and we just need to find out what the output would be. So let's take a look at the question. Initially it's assigning M equal to 10. So M's value becomes 10. Then we are declaring two integer variables n and n1. Now n equal to plus plus m. When we do plus plus m, it will increment the value of m first and then it will assign the incremented value to n. So plus plus m means m becomes 11 now, and that is assigned to n, meaning n becomes 11 now. Now the next statement is n1 equal to m plus plus. So when we are doing m plus plus, it will first assign the value of m to n1 and after that it will increment, meaning n1 is assigned the current value of m, that is n1 becomes 11, after that m is incremented, so m becomes 12 now. Okay. After that we are doing n minus minus. N minus minus means n is decremented, so n becomes 10. After that minus minus n1, that is same, n1 is also decremented, becomes 10. After that the statement is n minus equal to n1. N minus equal to n1 meaning n equal to n minus n1. n equal to n minus n1. So n minus n1 is 10 minus 10, that is 0. N becomes 0 now. Print of percentage d n. There we'll be printing n's value here. So n is 0 here. So the output of the program is 0. This is a C programming question. We have been given this particular code snippet and they are asking the output of the program is dash. So let's take a look at the program. What we are doing here is car star C equal to gate CSIT 2017. So we are defining a string C here as gate CSIT 2017. Car star P equals C. So P we are assigning to the same address as C. After that we are printing printf percentage d int of strlen of C plus 2p minus 6p minus 1. Return 0. What would be the output of this print statement? So let's take a look at the character pointer C. C is assigned to this string gate CSIT 2017. So in memory it will be saved like this, GATE CSIT 2017 in contiguous memory locations. So let us say the starting address is 100. Each character takes 1 byte to save. So if G's address is 100, A will be stored in 101, T will be stored in 102, etc, etc. 1 will be stored in 110, 7 will be stored in address 111. Now what will C have? C will have the starting address of this string, meaning C will have the address C 100 stored in it. Now car star P equal to C, meaning P will also have the same address stored in it. So C and P are pointing to this string, the starting of this string, that is starting in G here, which is at 100, which is at address 100. So let's take a look at this statement and see what happened. strlen of C plus 2 of P minus 6 of P minus 1. Now that we can rewrite as strlen of C plus P of 2 minus P of 6 minus 1. 2 of P we can write as P of 2. Similarly 6 of P we can write as P of 6 only. Now what would be P of 2 and P of 6? So P will return the starting address of this string, that is 100, but when we are calling it like this in this format P of 2, it will return the value stored in the second index. So P is pointing to 100 here, meaning P of 0 will return the value stored in the first index, that is G. Similarly P of 1 will return A, P of 2 will return T, meaning here P of 2 will return the character T, P of 6 will return the character I here. So this we can rewrite as strlen of C will have the address 100 stored here. So 100 plus character T minus character I minus integer 1. That is equal to strlen of 100 plus 84. 84 is the ASCII code of character T minus 73. 73 is the ASCII code of character I minus 1. That will be strlen of this, we can evaluate to 100. Now strlen will consider 110 as the starting address of a string. So if you take a look here, 110 is the address of the character 1 here. Starting from 1 we have only 2 more characters, 1 and 7 here in the string. So strlen of this will return the length of this string, that is the length of the string 17. That will be 2. So the answer to this question is 2.
Question. We have been given 4 pair of words and we need to determine which of them are not synonyms. Let us look at the options. Aversion and dislike. Both the words are similar in meaning and they state that something which you don't like or you avert from doing something, means you avoid something or you refrain from doing something. So both are synonyms of each other. So this option will be discarded. Next one is luminous and radiant. Again, both are similar in meaning, which conveys that something is letting off light or giving light something. As we say, luminous or extra luminous devices and something which is radiating or giving off light. So again, both are same in meaning or they are synonyms. So we'll discard this as well. Then third one is plunder and loot, and both of these again are synonyms of each other, which mean to steal something, and hence again this option will be discarded. Coming to the last one, yielding and resistant. Now as we know, yielding means to provide or produce something, while resistant is like it is same to aversion, means you are avoiding something, you are denying something or refusing to accept some fact or comply with something. So these both are different words and they are not synonyms of each other. and that is what we have been asked to find out. So we'll go with option D, yielding and resistant. This is a general English fill in the blank type of question. It is saying that Saturn is dashed to be seen on a clear night with the naked eye. And in this blank, we basically need to fill in two main words, which are enough and bright. We need to find out the proper arrangement of these two words, which will make the sentence meaningful. First, let us identify that this word enough is a preposition, while this word bright is an adjective. It is saying that the Saturn is bright. How is the Saturn? It is bright. So it is an adjective, and it is bright, but how much bright? So it is enough bright. Hence, it is a preposition and an adjective. And usually, going by the grammar rules, we place this preposition after the adjective. So first comes adjective, and then comes the preposition that will support it. Hence, in this particular sentence, we shall first put bright, and followed by that there will be enough. So Saturn is bright enough to be seen on a clear night with the naked eye. So we shall go with option B, bright enough. This is an aptitude based question on distance and direction. It is saying that there are 5 buildings called V, W, X, Y and Z in a row, and not necessarily in the same order, such that V is to the west of W. So let us place W over here, and now the direction will be like this: north, south, west and east. So V is to the west of W, which means V is over here. Z is to the east of X. Now we don't know where this X lies, so let us hold this sentence for a while. And next part is saying that and the west of V, which means this Z is to the east of X, such that if X is somewhere over here, then Z is to the east of X and west of V, means Z has to lie in the west of V, which means in this particular line of sight. So we can place Z over here in the west of V and then X over here, because all of them are in the same row actually. So there is no Y dimension over here. So these are the four buildings we got. And now W is to the west of Y, which means Y will be at the end. So this is the arrangement of those 5 buildings. And now we need to determine which building is in the middle. So we got building V to be the middle one. So the correct option would be A, building V. This is a mathematical aptitude question. It is saying that a test has 20 questions worth 100 marks in total. So there are 20 questions and 100 marks in total. Now there are 2 types of questions in the test: multiple choice questions worth 3 marks each and essay questions worth 11 marks each. So let us say there are A, multiple choice questions, and there are B, essay type questions. These are worth 3 marks each and these are worth 11 marks each. So we'll have the equation 3A plus 11B equal to 100, because the total marks of the test is 100, and A plus B equal to 20, because the total number of questions in the test is 20. So we can solve these two simultaneous equations together. Multiplying this with 3, this becomes 60, and we get 11 minus 3, 8B equal to 40. So we get B equal to 5, A equal to 15. So there are 15 MSQ type questions and 5 essay type questions. Hence we get what we are asked: how many multiple choice questions does the exam have? So we got 15 to be the answer. So we go with option B. This question is based upon probability. They are saying that there are 3 red, 5 green and 3 blue socks. So let us note them down: 3 red, 5 green and 3 blue socks. Among these we need to choose 2 socks and need to find the probability that they are of the same color. Now we need to assume that these 2 socks are picked up simultaneously and not one after another. So there is no replacement. We put in the hand once and we pick up 2 socks at the same time, and they need to be of the same color. So how many options do we have? Either we can have both red or both green or both blue socks. So if we want both of them to be red in color, then the number of ways would be 3C2. For green color it will be 5C2, and for blue color it will be again 3C2, which means the number of ways in which we can choose two socks of the same color for each of these three. And what's the total number of socks that we have? 3 plus 5, 8 plus 3, 11. So in total there are 11 socks, and among these 11 socks, if we were to pick up any two socks randomly, then that would have 11C2 ways. So the favorable cases which we have is the sum of these three, and the total number of cases is 11C2. So our probability will be like this. And on solving this particular expression, we get 3 plus 10 plus 3 upon 55, which becomes 16 by 55. So that is the probability of getting two socks of the same color among the given bunch of socks. So the correct option would be D, 16 by 55. This is a general English question. A paragraph has been given. We lived in culture and denied any merit to the literary works, considering them important only when they were handmaidens to something seemingly more urgent, namely ideology. This was a country where all gestures, even the most private, interpreted as political terms. So by this paragraph, the author is basically talking about two things. First one is literary works, and the next one is ideology. He's basically trying to give some information about a culture in which the people, the society have such an attitude that they deny any credit to the literary works if they do not comply with their own ideologies. They considered the literature important only if they were handmaidens, which means only if they served or only if they added fuel to their own ideology, and they were not ready to deviate from their own fake ideologies, basically. So by this paragraph, the author is trying to criticize that fake ideology and highlighting the importance of the literary works over any ideology. For him, the literature is more important than any personal ideology, and we should not change our attitude towards the literature based upon the facts that it is conveying. This is a country where all the gestures, even if the most private ones are there, all of them are judged based upon the political terms. So only if they comply with their political terms and their ideology, they would be accepted. So the author believes that ideology is not as important as literature is being revealed by which of the following words that we need to determine. Now, looking at the first option, culture, this particular words appear over here in the paragraph, and it simply implies that what that culture is actually doing. It is not talking about the author's beliefs. So this won't be the answer. Next one is seemingly, that appears over here. By this word, in this context, we see that this word seemingly more urgent is trying to add some weight to this sentence, conveying that author sees that thing to be more urgent, but that may not really be in its truest sense. So what seems to be the reality need not always be correct. In this particular culture, it seems that ideology is more important, but that is actually not. Literature is more important. So this seemingly meaning is highlighting what author actually believes. And so that could be our answer. Let us also look at the other options. Urgent, that appears over here. Seemingly more urgent. So according to the people, what is urgent? The ideology. So, but it is not adding to the fact about what author believes to be true. So even that cannot be the answer. And the last one, political terms. This word over here. Again, it is not talking about what the author believes. So we would go with this word seemingly over here. And that is our option B. This is a standard GK type of question you might have already seen. There are three boxes. One of them contains apples, one of them contains orange, and the last one has both apples and oranges. But all three of them are incorrectly labeled. So let us say these are their labels: apple, orange, apple, orange. Now if these are the labels and all are incorrectly labeled, then the contents of the first box can be either orange or apple orange. For this one, the contents can be apple, apple orange. The last one can have either apples or oranges. Now we basically need to determine the correct contents of all the three boxes in just one operation. And what is that operation? We can open just one box and pull out just one fruit blindly and inspect it. With this operation, you need to determine if it is possible to correctly determine the contents of all the three boxes, and if it is not, then you can go with the option D. Let us look at some of the choices which we have. Let us say you decide to open this particular box labeled as A, and let us say an orange comes out of it. Now you know for sure that this is labeled as apple, so it cannot contain just apples. It can contain either oranges or apple oranges for sure, which means this box is definitely going to have oranges, right? So whatever you pick out of it, you cannot for sure determine the contents correctly, because in this case also it is having orange and this case also it is having orange. So whatever you pick up, there is no definite answer you can give without opening one another box. So in just one go, you cannot determine the correct contents of all three if you decide to open either this box or this box, because again the same thing case will be with this box. If an apple comes out, then both these two cases are having apples, so there is no surprise if an apple comes out of this box labeled as orange. So again there is no meaning in opening this box. Now let us see if it is possible with the last one, otherwise we would go with option D. Now in this box, you know for sure that it cannot have both apples and oranges, right? It can have only apples or only oranges. So two cases, you pick up a fruit, it comes out apple. Now if it is coming out to be an apple, then you know for sure that this box is having apples. Now if this box is having apples, then what would be the content of the box A? Now it cannot have apples because that is already exhausted, so it will have apple orange. Now that is exhausted, so this box labeled as A would be having oranges. So we could correctly determine. Let us look at the other case as well. Let us say an orange came out of this box. So in that case, we would say that this last box is having oranges. Now if this is having oranges, then they cannot be over here. So now this will be having apple orange. And if that is the case, then this cannot have apple orange, it will have apples. So whatever comes out of this box, we can correctly determine the contents of the other two boxes as well, if we decide to open the last box which was labeled as both apples and oranges. So we should open the last box labeled both apples and oranges, and then only we can in just one go correctly determine the contents of all the three boxes. So yes, it is possible, and we would go with option B. This is a mathematics question based upon the precision rules. A number x has been given which has 30 digits. It starts with 4 and it is followed by all the 7s up to 30 digits. We actually need to determine the number of digits that the number x cube will have. Now definitely it is not possible to manually calculate this thing or even with the help of a calculator, because that's a 30-digit number and we do need to take its cube. So we won't go by that method. Let us see if we can do something with the help of precision rules. This number x can be written as 4.77 so on into 10 to the power. Now it originally had 30 digits, and out of that I have left just one decimal point, so 29 will go in the power. This is how you can write x in the precision format. Now if this is x, then what will x cube be? Taking cube on both the sides, I'll get this 4.77 thing into 10 to the power 29, this whole thing cube. Now I can distribute this cube to both of them, so that will be 4.77 cube into 10 to the power 29 cube. And what is 29? This thing will actually become 10 to the power 29 into 3, because a raised to m evaluates to a raised to m into n. So this thing will become 10 to the power 29 into 3, which is 10 to the power 87. So we have 4.77 so on cube into 10 to the power 87. This is the number x cube. Now how many digits is it having? Now this 10 to the power 87 is having 88 digits in total, because it will be 1 followed by 87 zeros. And how many digits will this number will have? 4.77 so on cube. Now we know that the lower number 4 is having 64, means 2 digits, and the upper number 5 is having 3 digits because its cube is 125. So this number lies in the middle of them. So we'll assume that its cube will also have 3 digits. So we'll say this is a 3-digit number and this is 88-digit number. But we know that when we say, for example, 5 cube into 10 square. Now this is having 3 digits, 125, and 10 square is having 3 digits again, 100. And when both of them are multiplied together, what is the number of digits in the result? 12500, which means 5 digits. 3 plus 2, 5. So applying the same thing over here, what we get is the number of digits in this number, that is 3, plus the number of zeros over here. 10 cube actually has 3 digits, but how many zeros does it have? 2 zeros. So we got 3 plus 2, which means the number of zeros only are being counted. So how many zeros are there in this? 87 zeros. 1 followed by 87 zeros. So the number of digits this x cube will have is this 3 plus the number of zeros it is getting from this number, that is 87. So the sum is 90. That would be our answer for the number of digits in x cube. So option A. This question is based upon algebra. We have been given an expression e raised to x plus half x squared minus 2 equal to 0, and the range or interval given is -5 to 5. We need to determine the number of roots this equation would have in this given interval. Now this is not a simple polynomial or quadratic equation which we could manually solve and then check how many values of x satisfy and lie in that interval. That's not feasible in this case because this is a mixed type of function. It is having exponentiation as well as this polynomial term, so we can't do that directly. So instead of solving this equation, let us think about some other way in which we could determine the number of roots directly without actually finding the roots. So one thing that comes to our mind is intermediate value theorem. Just like we have the mean value theorems, this one is intermediate value theorem, which says that, let us say in a given interval, the function is changing its sign. Let us say it was earlier positive and then it became negative. Or if it was earlier negative, then it became positive. Means it is changing its sign in that interval. So if it is changing sign, then definitely at some point it would have become 0. Then only it can change sign from positive to negative or negative to positive. So in the given interval, if our function is changing sign, we would say that it is having a root. But how many roots? That we don't know. Let us say this is an interval and the function is something like this. So it is changing its sign multiple times. So you just checked for once that yes, it is changing its sign once, means it is having root, but you don't know actually exactly how many roots it will have. So for that we need to look at the monotonicity of that function, that if it is increasing or decreasing. Now looking at our function, let us say f of x equal to e raised to x plus x squared by 2 minus 2. Let us check in the interval, let us say -5 to 0. Close to -5, if we substitute -5 exactly, then the value we get is approximately e raised to -5 plus 25 by 2 minus 2. Now this thing will approximately be 0, it would be very less. This is about 12.5 and then -2. So this thing is definitely positive, right? And if you substitute some lesser value, let us say -1, then for that value it becomes e raised to -1 plus half minus 2. Now this is half and this is again a small thing and we are doing -2. So this has become negative now. So the function has changed its sign, which means it would have had one root, and in the middle we don't see any point at which the function would have changed its monotonicity. It seems to be strictly decreasing in this interval from positive to negative, which means it would have had one root over here. We can also check for 0. The f of 0 becomes e raised to 0 plus 0 by 2 minus 2. this thing is 0, this is 1. So 1 minus 2 minus 1, again this thing is negative. So this function is strictly decreasing from -5 to 0. It would have gone from positive to negative this way. So it has one root in the interval -5 to 0. Now let us check for the interval 0 to 5. For 0 we already saw that it is negative. Let us check for 1. For 1, f of 1 becomes e plus half minus 2. Now this is half and this is e. The value of e is approximately 2.2, about 2.1, greater than 2, and then we are adding something to it and subtracting 2, which means it is positive. So for 1 it is again becoming positive. And similarly for 4 or 5, if you will check, e raised to 4 plus 16 by 2 minus 2, again this thing is positive. So afterwards it is positive. So between 0 to 5 it is again changing from negative to positive, and the function is strictly increasing in this interval. So in this previous part it was monotonically decreasing, and in the next part 0 to 5 it is monotonically increasing, and hence in this interval also it will have exactly one root. So our function is changing its sign only two times, one between -5 to 0 and once between 0 to 5. So this function will have exactly two roots in the interval -5 to 5. So our answer will be 2. The number of roots this equation has in the given range are 2. This is a data interpretation type of question. The information is given as follows. An air pressure contour line joins the locations in a region having the same atmospheric pressure. The following is the air pressure contour of a geographical region. The contour lines are shown as 0.05 bar intervals in this plot, which means if there are two regions A and B and they are connected by a contour line, then it would be indicated that both of these regions are having the same atmospheric pressure. And if there are two adjacent contour lines, then there would be a difference of 0.05 bar indicated by them, which means if this first line is having a pressure of 1 bar, then the adjacent line would be having the pressure of 1 plus or minus 0.05 bar. So this is how it would depend, like we need to take either positive or the negative, but there would be a difference of 0.5 between any two adjacent contour lines. Now they are saying if the probability of thunderstorm is given by how fast air pressure rises or drops over a region, which means we are not concerned if the air pressure is very high or if it is very low. We are concerned with is only if it changes rapidly, which means it was earlier, let us say 5 bar, and then it became suddenly 1 bar. Or if there is a huge number of lines crossing a particular region, then the air pressure would be changing that many times in that area, because between every two lines there would be a difference of 0.5. So if there are four lines, then let us say this was at 1 bar, then this would be 1.05, 1.1, 1.15. So these four lines indicated that the pressure changed by four times of 0.5, so there 0.05. So that many times the difference would be created. Now in this particular graph we need to determine which of the following region is most likely to have a thunderstorm. Means the region in which the air pressure is changing very rapidly, or there is a huge difference between 2 points in the same region having different air pressures. So let us have a look at the graph, which is a bit unclear, but we can understand it this way. Let us have a look at this region P. Over here, this is our P. There are just two contour lines. The first one is having a pressure of 0.9 and this one is having a pressure 0.95 because they're adjacent to each other. So the lower one will be having 0.85, or it can also have 0.95, but there is not a huge difference over the region P because there are only two contour lines in these regions. So just a difference of 0.505 being created. So this cannot be our answer. Let us now look at the region Q, and from this region Q we can see that no contour line is passing. So this overall region is having the same air pressure. It is not changing at any point. So definitely there are no thunderstorms possible in this region. Now let us look at R. Over here we can see there is a huge concentration of these contour lines. We can see 1, 2, 3 and 4 contour lines, and this one also touching it. So there are 5 contour lines lying along this region. So the air pressure would change by 0.05 bar between every two lines. So if this is 0.65, next one is 0.7, then it will be 0.75, 0.8 and 0.85. So it is changing from 0.65 to 0.85. So this can be said to be the huge difference between the pressures at the same location. So this region R is more likely to get a thunderstorm as compared to others. So that could be our answer. Let us also look at S. In this region, there is just one contour line intersecting it, and this one is surrounding it. This is having 0.9 and the internal one is having 0.95. So again, that's not a huge difference, just of 0.05. So it's not very likely to get a thunderstorm. So we would go with option C, which is the region R being most likely to get a thunderstorm, as there is a huge difference between the pressures at two different points in the same region. So the answer would be R.